Hello everyone, my name is Abhishek and welcome back to my channel. This is the very first episode of Observability Zero to Hero series, and in this video we will learn about the fundamentals of observability. So this is a very important episode. Make sure you watch this video till the end. Now, because this is the very first episode of the Observability Zero to Hero series, let me take a couple of minutes to explain the course syllabus and where can you get the notes for each episode of the series. If you go to this GitHub repository called Observability Zero to Hero, you will find the link in the description as well as pinned comment. Once you head here, you can see a README file which explains the complete course syllabus. So this is going to be a 7-day observability tutorial series where in each episode we will cover a concept of observability. Starting with today, that is day 1, where we will learn about the fundamentals of observability, such as what is observability, why do you need observability, what are 3 pillars of observability, how observability is different from monitoring, and what tools are we going to cover in this series. Then in day 2, that is the next episode, we will learn about the monitoring part where we will use Prometheus. So what is Prometheus? The architecture of Prometheus, how to install, set up and configure Prometheus on a EKS cluster. Along with that, we will also learn how to use Prometheus as a data source in Grafana, and we will play around with few dashboards. So this is going to be theory and practical, and from day 2, all the episodes are going to be theory plus practical. Then in day 3, we will move towards little advanced concept of Prometheus, where we will learn about PromQL, Prometheus query language. We will understand how to write basic PromQL queries, advanced PromQL queries, how do you scrape the metrics, what kind of information you can get from PromQL, that is the Prometheus query language. In day 4, we will head towards even more advanced concept of Prometheus, that is how do you instrument custom metrics. So for that, we will learn about Prom client library, which is the Prometheus client library, using which how can you scrape the custom metrics, how can you define custom metrics. Along with that, we will also learn about alert manager. How can you alert to your Slack or send an alert to the Slack, email or other things. In day 5, we will move towards another pillar of observability, that is logging. So we will use EFK stack. Both ELK stack and EFK stack are very popular. We will use EFK stack, that is Elasticsearch, Fluentbit and Kibana. So we will learn how to do the aggregation of logs as well as visualization of logs. In day 6, we will cover another pillar of observability, that is tracing. So you will learn what is tracing, what exactly is distributed tracing, about some concepts like Open Telemetry. So whichever programming language you are using, there is a concept called Open Telemetry, which is bunch of APIs and SDKs, which will help you instrument traces, metrics, as well as logs. So we will also learn a little bit about Open Telemetry and we will play with Jaeger. So these are 6 episodes, and the final episode, apart from the 3 pillars of observability, we will also learn about eBPF in this series. So I'll explain what is eBPF, how eBPF is revolutionizing the space of observability over the last couple of years, and we will learn the advantages of using eBPF in your observability stack. So these are going to be the 7 episodes in which you will learn observability. Even if you are a beginner to observability, if you have knowledge of Kubernetes, basic knowledge of Kubernetes, you can learn observability. Because overall, we are going to learn observability on Kubernetes. Okay, now Abhishek, where can I get notes of this series? So you don't have to go to any other place. The notes is shared in the GitHub repository. You don't need to download it from internet, or you don't need to go to the Telegram channel. The complete notes right from day 1 to day 7 is shared in the day wise folders. You can go to a particular day. Let's say you go to day 4 and you can see the complete theory part that is explained in day 4, along with architecture diagrams, images, and not only that, you will also see the scripts used in the video as well as any YAML manifests. So you will get the complete copy of what is explained in the video. After watching the video, any particular episode, you can go to these notes and use it as revision material. So that's all about the core syllabus as well as the notes. Now let's move to the first topic of this series. What is observability and why do you need observability? Let's start with these things first. The textbook definition of observability says if you have observability setup, you can get the information about the internal state of the system. So what is system here? It is basically your application along with the infrastructure required by your application and the networking. So the definition of observability says if you have observability in place, you can understand the state of your application. Is it working as expected, or are there any failures? You can understand the state of your infrastructure, and you can also understand the state of your networking. Maybe something like the latency or the HTTP traffic, all those things. Let me give you some examples so that you can understand the definition better. If you have observability in place, you can get the information like what is the disk utilization of a particular node on my Kubernetes cluster over the last 24 hours. Why do you need this? Because you want to understand if the disk utilization is 100% at any point of time, or is it constantly 90%, or is the disk underutilized? Maybe if it is only 20% all the time. And you can also get information like what is the CPU utilization of a particular node of the Kubernetes cluster. Because if the CPU is 100% utilized, your system does not perform better. If the CPU is only utilized 10% all the time, then you need to reduce the CPU on your node because you are wasting a lot of resources, wasting a lot of money. Similarly, it can be memory. What is the memory utilization? Not only the utilization things, but you can also get the things like out of 100 HTTP requests or out of 100 API calls that are made to my application, what is the number of requests that were successful? What is the number of requests that were failure? You can also get this information. So this is all the what part of observability. So using observability, you can get information like what is the state of my system. It can be the disk utilization, CPU utilization, memory utilization, or even the number of HTTP requests that are failed or passed. But observability does not stop here. It will not only tell you what is the state of your system, but it will also help you understand why is your system in that particular state. So using observability, you can understand out of 1000 HTTP requests, let's say if 5 are failure, you can also understand why the 5 HTTP requests have failed. What is the reason for it? In which part of the application the request is failing? You can get complete information about the failure. Also, you can understand why there is a memory leak, which is causing extra memory usage by a particular application. And observability can also help you with how to fix these issues. So observability can help you with understanding what is the state of the system, where you can see if there are any issues with the system. It can also help you with why your system is in this particular state, and you can also understand how to fix it. How to fix the 5 HTTP requests that are failing. So you can get the complete traces of these HTTP requests, how the HTTP request has passed through the load balancer, when did it reach your front end application, then back end, then to the database, where exactly is the HTTP request failing. Once you get that information, you can fix the particular request. Same happens with the memory leak as well. If an application is using more amount of memory, using these traces, you can understand which part of the application is using memory extensively and how to fix it. So using these three concepts, what, why, and how, observability becomes very, very robust. But Abhishek, how can observability do so many things? So there are 3 pillars of observability. As you can see, the first pillar is metrics. The second pillar is logging. And the third pillar is traces. So metrics, logs, and traces. If you have set up metrics, logs, and traces for your application, and if you have the applications in place for tracking the metrics, logging, and tracing, you have set up observability. So the metrics part is basically responsible for understanding what is the state of your system, whereas the logging part is responsible for understanding why is your system in this particular state, and the traces can help you understand how to fix the particular state. If you take the same example, let's say a HTTP request or a API call to the application is failing. If you take this as an example, using the metrics, you can understand that, okay, a HTTP request is failing, and over the last 30 minutes, 10 HTTP requests failed. Over the last 24 hours, 100 HTTP requests failed. You can get this historical data using metrics. Whereas coming to the logging, you can pick up one HTTP request. Using this historical data, you can identify the timestamp. Okay, at 10 o'clock, a particular request has failed. So you can go to the logs of that particular application. You can see what happened at 10 o'clock, who sent the HTTP request, to which part of the application did that HTTP request hit, and why exactly is that HTTP request failing. Then you have traces, where traces is a very interesting concept. It can help you with the complete HTTP request tracing. That is right from the point of client. So client has sent a request to the load balancer. From load balancer, the request went to the front end. From front end, it went to the backend, and from backend, it went to the database. So using traces, you can understand how the request went to the load balancer. From load balancer, did it go to the front end? If it go, how much time did it take? Did it take 5 milliseconds? Is it expected or not? From front end to the back end, again, how much time did it take? Did it actually go to the back end? If it go, how much time it took at the back end? And to which backend did it go? Did it go to the expected backend or any other backend that is configured? And finally, if the request went to the database, all this tracing information can be taken care using the traces. So it can also help you with how to fix the issue. So what, why, and how are covered by metrics, logs, as well as traces. So if you learn metrics, logs, as well as traces, you know the complete observability. Now the big question is, Abhishek, is this responsibility of a developer or DevOps engineer? Is observability taken care by developers or DevOps engineers? We will learn this towards the end of the video. Don't worry. But right now, let's focus more on metrics, logs, and traces. Like Abhishek, can you explain in little bit more detail what exactly is metrics? Sure. So metrics basically gives you historical data of the events. So if you take any particular event, so the event can be the CPU or memory utilization or disk utilization, or it can be the HTTP request, right? These are all the events. So using metrics, you can get the historical data of the events. That means over last 30 minutes, let's say, what is the state of the CPU? What is the state of the memory? What is the state of the disk? What is the state of the HTTP request? So you can track all that historical information using metrics. This will help you understand if the CPU is overutilized, underutilized, partially. That means once in an hour or at a particular time of the day, if your CPU utilization is at its peak. Sometimes you might see that throughout the day, the CPU utilization is very normal, but at one point of the day, the CPU utilization went to its peak and then again it is back to normal. Assume this is causing some issue with your application. How would you understand? If you don't have historical data, if you just have the current data, current state of the application, you can never understand why your application went down at 10 a.m. in the morning today or 10 a.m. in the morning 10 days ago. If you don't have this historical data, there is no way you understand what is the issue. So for that, you need metrics. It gives you historical data of all such events. Now the next thing is logs. I think many of you are familiar with logs already. So logs basically helps you understand your application better. If a developer is setting up proper logging for the application, there are different types of logs, right? You have info log, you have debug log, you have error log, trace logging. So there are different types of the logs. So if a developer is logging these things, or if a developer is instrumenting these logs, you can understand your application better. So at 10 a.m. in the morning, using the historical data, you understood your application went down. That is, CPU utilization is high. You can go to the logs of that particular application. You can go to 10 a.m. logs and you can see which request was sent at 10 a.m. And in the logs, you can see which part of the application, which package of the application, which module of the application was hit during that time. And that will give you information that, okay, so this is why the CPU utilization was high, or this is why the memory utilization was high, because the part of the application that the HTTP request hit is leaking memory, right? So logs will help you understand furthermore about what is issue. Finally, like I said, you the traces part. I think I have explained the traces part very clear here. If you have traces along with the logs, so logs will give you some amount of information. Traces will give you extensive information to debug, troubleshoot, as well as fix your issue. Now, a big question that people have is, Abhishek, what is the difference between monitoring and observability? Are they the same things? Like, people ask for monitoring in the interviews. Is monitoring same as observability or is it different? Let me tell you, out of three pillars of observability, that is metrics, logs, and traces, monitoring only focuses on one pillar of observability, that is metrics. Along with metrics, if you have alerts and if you set up dashboard, that is basically monitoring. So monitoring only covers one pillar of observability, that is metrics. Along with metrics, it will also implement alerts as well as dashboards. So when you say a application with perfect monitoring, you need to have the historical data of the application. That is, you need to have the metrics. Then if the metrics are reaching a particular point, if CPU is reaching 80%, then you can send alerts either through Slack or email, or let's say any other platform that you are using. And you can also record this information in dashboards like Grafana. So we will cover the complete monitoring. We will not only cover metrics, but we will cover the complete monitoring in this series. You will learn metrics, you will learn alerts, and you will also learn how to see the dashboards on Grafana platform. So monitoring and observability, they are not same. Monitoring is a sub part of observability. Observability is a whole thing where you can get the feedback of your complete system. Abhishek, can you explain an example like in real time? Why does a company need all this information? Like if there is an issue in production, they can immediately react on the issue, right? Why do they need to spend so much amount on observability to get all of these insights? Let's take a practical example so that you people can understand. So assume you're working in an organization. Let's say this is a product based company. So this is a real time use case that I'm explaining. So you're working in a startup where the startup has built, let's say, a application like resume builder. So this is their application, and you have deployed this application on a Kubernetes cluster on the AWS infrastructure, and you have set it up with a proper networking, let's say within a virtual private cloud. Now once this everything is done, like your application is built, you have deployed it on Kubernetes, you have AWS, the next goal would be to search for customers, right? You need customers, you need to sell the product to the customers. So you would look around for the customers, or your organization would look around for the customers. And quite obviously, when you find a potential customer, the customer will say that there are other resume builders in the market? Why should I go with your resume builder? My employees can use any other resume builder. So you would tell the customer, okay, look at our service level agreement. So if you are not from SRE background, so service level agreement, you can understand as a basic agreement. So your organization will tell the customer, we can sign a service level agreement with you, where in the agreement, we will define some objectives. Basically, you will make some promises to the customer. Objectives are nothing but the promises that you are making. Like what? You will tell the customer that 99.9% of time, my platform will be available. That is, my resume builder application, there is only chance of 0.1% of it going down throughout the year. Or another objective that you write to impress your customer is, out of 10,000 requests that are sent to our resume builder, at least 99,995 requests respond back in 30 milliseconds, and that too with 200 HTTP status code. That is, out of 10,000 HTTP requests, 99,995 requests respond back in 30 milliseconds with success code. So your customer, the potential customer, if they are impressed, they will take the subscription of your resume builder and your organization is happy. But is everything done? No. This is where the actual thing starts. So you have signed multiple SLAs with different customers and you have promised some very strong objectives. How do you make sure that you are meeting the expectations of your customer? You don't want your customer to come back and say, hey, your service level objectives are not met, or the promises that you made are not fulfilled. Even before that, you need a continuous feedback system in your organization. So let's say you promised for 99,995 requests to be responded back in quick time. You need a feedback system where this feedback system, even if one request is failing, because you just have a error budget of 5 requests. So even if one request or 2 requests or 3 requests are not meeting the expectation, you immediately need to take an action. So you need a system that gives complete feedback about the internal state, and that is observability. So in these cases, a strong observability platform is required so that you can get complete information about what is the state of the system. Is the state meeting the expectation of service level objectives that I've signed with my customer? If part of the requests are failing, like let's say 3 requests are failing, why are they failing? Because right now they are 3, which is fine. But if 5 requests are failing, one of your objective is not met, then your organization will have a problem. And immediately you need a feedback, like how to address it, how to immediately fix it, so that we don't reach to a point where 10 requests are failing or 15 requests are failing. Immediately, if 1, 2, or 3 requests are failing, if you take action, you will not go to a state where 5 requests are failing and you fail your customer promise. So this is a real-time use case of observability. Typically, companies with strong SRE principles. So if a company needs SRE, the first thing that they have to do is they have to implement observability. So Abhishek, is it only required for such companies? No. Even for companies like Instagram or companies like Facebook, these days, every modern application needs observability, because when you have end users, it can be even a banking application, can a banking application, will it be fine if 5 users are facing an issue? No. Will it be fine if the request to the banking application is taking a lot of time? They would be fine if the request by a particular user is taking 5 seconds, let's say, or they would be fine if the request is taking 10 seconds. But if the request is taking 20 seconds, they would not be fine. So immediately, if the request is taking more than 5 seconds, the observability system should alert the developers of that banking software so that it will not move from 5 to 10, 5 to 10, 10 to 20. Okay, now I think you might have got understanding of observability and how it will help the organizations. Now the final thing is it a developer's responsibility or is it a DevOps engineer responsibility? So there is a long debate like observability has to be implemented by the developers or is it by the DevOps engineers? Is it by the SRE engineers? Let me tell you, observability is always a collective effort. There is no way only the developers or only the SRE engineers, only the DevOps engineers can implement observability. If you understand it carefully, there are two primary parts, right? So the first part is that whenever you have your application along with your infrastructure and networking, the first thing is your application should instrument the metrics. That is, your application should throw some metrics or your application should instrument the logs. The developers of the application should actually write the info logs, debug logs, error logs, any other logs. And the developers of the application, they should also implement the traces. So if the developers are not instrumenting or implementing the metrics, logs, or the traces, there is no way the DevOps engineers or the SRE engineers, they might use the tools like Prometheus or they might use strong tools like ELK-stack or anything like Jaeger. But nothing is going to happen if the developers are not instrumenting these things. These things are fed to the platform, right? Metrics are fed to Prometheus or Prometheus will look for the metrics. ELK-stack would look for the logs. Distributed tracing platforms would look for the traces. If these are missing, these platforms cannot do anything. Similarly, if you have metrics, logs, and traces set up by your developer, I mean, instrumented by your developer, but you don't have these applications deployed on your Kubernetes cluster, again, there is no use. So it is a collective effort where developers will instrument the metrics, logs, and traces, and DevOps engineers will do the implementation part. So they will set up the monitoring stack, they will set up the logging stack, the distributed tracing, so that for end users, it can be your management, it can be your QE, or it can be any other team. Even it can be developers, they can look at the platform. Like once you have ELK stack setup, let's say, so they can use the logging stack to query a particular error over the different applications. So it is a collective effort. In this series, we will learn from DevOps and SRE engineers point of view. How do you install, set up, and configure these things? Along with that, we will also cover some part from the developer's point of view, where we will see like using Open Telemetry. How can developers instrument the metrics, traces, and logs? Because Open Telemetry is the popular CNCF platform. It is collection of APIs and SDKs. This is not a single utility or a tool. Basically, Open Telemetry is the group of APIs and SDKs which can help the developers get these things, like instrument these things. So we will also learn that also using Prom client, which is for Prometheus, specific to Prometheus, we will see how developers can scrape the metrics. So These things will be covered in the series. I hope you found today's video informative. Let me know in the comment section. Did you find it useful? Are you excited for this series? Going ahead, we will do theory plus practical of each of the concepts that we have learned in today's video. See you all in the next one. Take care. Bye bye. Hello everyone. My name is Abhishek and welcome back to my channel. Today is episode 2 of Observability Zero to Hero series. In the first episode, we learned about the fundamentals of observability. In this video, we will learn about metrics as well as monitoring. So we will start with the first pillar of observability, that is metrics. Let me explain in detail what are the things that we are going to learn in the video. We will start with understanding what is metrics using a real life example. Then we will understand the difference between metrics and monitoring. A lot of people fail to understand this difference, but I'm sure after watching this video, it will be very clear. Then we will learn what are some of the example metrics, that is commonly used metrics by DevOps engineers or SRE engineers, which they deal with on day-to-day basis. Then we will head towards learning Prometheus. So we will learn what is Prometheus. We will learn about the architecture of Prometheus, because Prometheus is the most popularly used monitoring tool in the world of Kubernetes. So we will learn what are the different components of Prometheus, such as the push gateway, retrieval, time series database, alert manager. We will try to understand what all these components are. Then we will learn how to install Prometheus on a EKS cluster. Finally, we will learn how to configure Prometheus as a data source in Grafana. That is how to install Grafana, how to set it up and integrate it with Prometheus for visualization. So we will cover all of these things in today's video. If you want to refer the notes, like after watching the video, if you want to do a very quick revision, you don't have to go anywhere. Just go to this repository, Observability Zero to Hero, go to the Day 2 folder, and in the Day 2 folder, you will find a README file. And this will explain everything that I have covered in the video, along with diagrams, architecture, and you can also find the commands that I'm using in the video. So it will be a very quick revision thing. So make sure after watching the video, spend 15 to 20 minutes on this. Okay, now we are clear about what we are going to learn. So let's start with what is metrics. Let's take a real life example. So assume there is a patient. So a patient is admitted in the hospital. Assume the case. So obviously a nurse would be assigned to the patient, and nurse would attend the patient periodically. That means every 15 minutes or 30 minutes or even once in an hour, depending upon the criticality of the patient, nurse would attend the patient and collect some key information or data points about the health of the patient, such as the blood pressure or the heartbeat of the patient and anything that is important. So the nurse would keep a note of this information. That is, at 10 a.m. in the morning, if you assume nurse attends the patient once in 15 minutes, so 10 a.m. in the morning, the heartbeat is 76. Then at 10:15 a.m. in the morning, heartbeat is 81. Throughout the day, nurse would collect this information. Similarly, nurse would collect same information for the blood pressure and anything else, right? So throughout the day, nurse would collect this information. Why? Because at the end of the day, if doctor wants to understand the health of the patient, is the patient's health stable? Is the patient doing good? How can the doctor understand? By looking at this information. So doctor looks at the periodic information of the heartbeat, periodic information of the blood pressure, and if everything looks normal, that is in the 15 minutes interval throughout the day, if everything looks normal, then doctor would decide that the patient is okay, in a good condition. Let's say there is a abnormality at one particular time of the day. Maybe after medication, it is noticed that the patient's heartbeat goes down, or during the sleep, the patient's heartbeat is just above the average good condition. Then doctor would decide that, okay, patient needs more time at the hospital, or patient needs to be critically observed. Assume if doctor does not have this information, how would doctor understand the health of the patient? It's not possible. So these things, like this is a metric and this is another metric. So these things are called as metrics. So metrics are nothing but periodical information or historical data. So if you want to get a definition, so I would say historical data of the events to understand the health of the system. That is nothing but metrics. So using metrics, you can understand if a system is in the good condition or not in the good condition. But one problem with metrics is that it is complete raw information. That is, all this information is written on maybe a notepad, or this is written in a Excel sheet. So it is quite raw information, which is not easy to read. And also, because this is too much numerical information, at 10:15, the heartbeat is 81, at 10:30, heartbeat is 62. So too much of numerical information, you might also miss some things. So what is the right way to deal with metrics is that feed the metrics to a monitoring system. Even if you look at the hospital, you can see that the heartbeat of the patient is continuously collected either by the nurse or using a machine, right? Because if the heartbeat has to be collected every 30 seconds, nurse cannot do it. So you need a machine that is connected to the patient, which records these metrics. So what actually happens is this metrics is fed to the monitoring system, or the monitoring system reads the metrics and represents the metrics in a graphical format or in a dashboard that is easy for anyone to read. Let's say I give you a lot of data in an Excel sheet versus a graph or versus a pie chart. What is easy to read? Obviously, the dashboard, the graphs, or the pie charts are very easy to read. So monitoring system collects the metrics or scrapes the metrics, which is like pulls the metrics and represents the metrics in a dashboard format. It can be any kind of the dashboard so that it is easy to understand. If there is a spike, you can clearly see in the dashboard. Maybe in the raw data, in the notepad or in the Excel sheet, you might miss that information. But if you are seeing a graph, you can clearly see the spike in the graph. So the dashboards are much better. Not only that, in the monitoring system, what you can also do is you can set an alert. That is, you can set an alert saying if the heartbeat of the patient goes above 90, send a notification or send a text message to the nurse or send a WhatsApp message to the nurse. And if the heartbeat goes over 110, send a WhatsApp message to the doctor that you need to immediately attend the patient, right? So a monitoring system is basically getting the information from the metrics or scraping the information, pulling the information from the metrics and representing that information in a well readable format using the dashboards. And it is also capable of firing the alerts when something is wrong, right? Firing alerts is basically notifying. The heartbeat of the patient is down. You need to immediately take an action. So it can read the metrics, it can represent the metrics in the dashboard format, and it can also send an alert or fire an alert when something is wrong. That is a monitoring system. So metrics is a subpart of monitoring, or monitoring depends on the metrics, but it is much more than that. Now, Abhishek, can you explain this scenario in the world of IT? So this is very clear. I got understanding of what is metrics and what is monitoring. So if we try to understand this in the world of IT now, I hope this will be much easier now. So assume there is a application, just like a patient, you have a application that is deployed in the AWS environment on a Kubernetes cluster, let's say. So the nodes of the Kubernetes cluster are AWS virtual machines, and there is also AWS networking like virtual private cloud. To understand the state of this entire system, not only of your application, about the Kubernetes cluster, about the AWS infrastructure, even if any of these things is not right, your application will not be stable, or your application cannot be up and running 24/7. There will be some bad user experience. So to monitor the system or to understand the health of the system, what you would need is metrics. Just like we understood the metrics of the patient, similarly, there would be metrics for the complete system, such as the CPU of virtual machines on AWS, which are nothing but the Kubernetes nodes. So what is the historical information of the CPU of the nodes? At 10 a.m., what is the CPU utilization of the node? At 12 p.m., what is the CPU utilization of the node? So that you can understand whenever there is an abnormality. Maybe in the evening, your application is receiving a lot of requests and CPU went up, something like that. Similarly, you can also collect another metric such as the memory of your AWS virtual machine. This is some examples of infrastructure. You can also gather metrics for the Kubernetes cluster, something like the pod status. How many times the pod went into crash loop back off throughout a day? and at what time the pod went into crash loop backoff, or the deployment status. Or if you are using, let's say, a HPA, you can also see the replicas of deployment. That is, throughout the day, at what point of time you have 10 replicas, 2 replicas, things like that. And you can also collect some application specific metrics. For example, the HTTP requests received by your application, total number of HTTP requests received in a day, or at 5 a.m. in the morning to 6 a.m. in the morning, is your application even receiving traffic? You can understand that using HTTP requests. Or it can be too much application specific, something like maybe if you're using a e-commerce application or a tech platform, where you want to get the metrics like how many users have signed up in the last 30 days and at what time the users are usually signing up. If there is a new account creation, at what time of the day is it happening? At what time of the day are the users deactivating from the platform? Or it can be how much time users are spending on the platform, right? Anything that is user specific, you can also collect such metrics. So all these metrics, depending upon your company, you can collect hundreds of metrics, or you can collect just 10 metrics, or you can collect some 50 metrics. There is no requirement, or there is no recommendation as well. It depends how many number of metrics that you want to collect to understand the health or the status of your system. Okay, now Abhishek, we have collected this metrics. How about monitoring? Exactly like the same example, these metrics are either fed to the monitoring system, or monitoring system will automatically pull these metrics. It can be the push mechanism, or it can be the pull mechanism. We will use a common word called as scraping, which can be understood as pull. Remember this word, I might be using a lot of times. So either the monitoring system will get this information, somebody will push this information to the monitoring system, or monitoring system will scrape this metrics, pull the metrics, and it will represent this information in a visualization format. That is the graph format, so that you can select this graph time period as 30 days. Best example is your stock market, right? If you go and select a particular stock, you can select last 10 days, last 1 month, last 1 year. How are you getting that graphs? It is from the metrics that is collected, that on one particular day, at one particular time, this is the price of the stock, right? So that information, the historical information, is your metrics. And who is creating that graph? Your monitoring system. It is taking the information and representing the information in a dashboard format. And in this monitoring system, you can also fire alerts. If the CPU utilization of a particular node goes above 80%, fire an alert. If the disk utilization of a virtual machine on AWS, which is used as a node in the Kubernetes, if the disk utilization goes above 75%, send a Slack message in the DevOps engineering team group, or in the SRE engineering Slack team group. Similarly, you can do it for any kind of thing. Let's say a lot of users are deactivating the platform. Even for that, you can create a matrix. Or if users are seeing a latency, that is, if the HTTP request processing is taking, let's say, usually if it takes 5 seconds, you have noticed it is taking 10 seconds. And if this 10 seconds is seen 30 times in a day, fire an alert to the Gmail or Slack of development team. So you can configure these kind of alerts. So I hope you understood what are the metrics. So these are some of the metrics that you collect or the system collects. It can be a application, it can be a plugin, anything that collects these metrics, and monitoring system pulls these metrics, represents in the dashboard format, and in the monitoring system, DevOps engineers or SRE engineers creates this alerts rules. So when to fire the alert, where to file the alert. So this is about monitoring. So I hope you understood the difference between metrics and monitoring now. Monitoring is a superset where it has metrics, it has dashboard as well as alerts. Okay, now Abhishek, where did Prometheus come into picture now? So Prometheus is the top or very popular open source monitoring platform in the world of Kubernetes. So Prometheus can scrape the metrics, or Prometheus can also be sent the metrics. Somebody can also send metrics to Prometheus. But popularly, what this Prometheus does, okay, so it will pull the metrics from various sources. I'm going to cover this thing as well, how Prometheus collects huge amount of metrics. There are things like exporters. There is something called as kube state metrics, and there is something called as metrics endpoint of the application, which I'm going to cover in next 5 to 10 minutes. But Prometheus pulls various metrics from your AWS or your Kubernetes cluster, represents them in the dashboard format, and in the Prometheus, you have a component called alert manager, and you can configure this alert manager to fire the alerts. Abhishek, I want to understand detailed architecture of Prometheus. No problem. If you go to the documentation, day 2 folder, in the README file, just scroll down and zoom out. Let me zoom out. So you can see here, this is the complete architecture of Prometheus, where this is the Prometheus server, the component that you are installing. And in the Prometheus server, there is a sub component, or there is a part called as retrieval. The arrows are pointing towards the wrong direction. So actually it is pull metrics. So retrieval pulls the information from exporters. Today, if you are not understanding anything like exporters or push gateway, don't worry. We will play with them day 3, day 4 as well. But Prometheus will pull the information from exporter or the push gateway, where any application can forward the metrics to the push gateway. Prometheus will pull that information, and Prometheus stores that information in a time series database. For simplicity, if you are complete beginner, ignore this push gateway for now and understand Prometheus, the retrieval in the Prometheus pulls the metrics from the exporters, and it will store that information in the time series database. What is a time series database? Basically, in the metrics, time is very important, right? So whenever you are storing time along with the key value pairs, right? So at this particular time, that is 10 a.m. in the morning at 6 seconds, the heartbeat of the patient is 81 or 71, right? So along with the time, you are also storing some key value pairs. So this is called as time series database. I explained this for simplicity. We will play with the matrix time series database. Don't worry. So, okay, the information is stored in the time series database, and if you want to get that information from Prometheus, let's say you want to get the information for last 20 minutes, last 30 minutes. Okay. So you can query the HTTP server of Prometheus. Prometheus supports something called as PromQL, Prometheus query language, right? To get information from Prometheus, that I want the information from last 30 minutes. So you can write a PromQL query. We will write some PromQL queries. We will learn how to write them. So when you pass that PromQL query to the Prometheus HTTP server using the user interface, right? Prometheus will give you that data back, which is taken care by the HTTP server. When we use the user interface, some of these things will become clear to you. And like I told you, you can also use the alert manager to fire some alerts. Okay, Abhishek, it can read information from exporters. What if I have some specific metrics that are sent by my application, right? In the Kubernetes cluster, I can have multiple applications. How can I tell Prometheus that, okay, out of 100 applications that are in my Kubernetes cluster, only read metrics from 50 applications, or only read metrics from 30 applications? So there is a concept in Prometheus which is called as service discovery. Using this service discovery, you can tell Prometheus that, okay, these are your targets, right? So as we keep using Prometheus, you will understand more about the Prometheus architecture. One thing to note is Grafana. So Grafana has strong visualization, like the strong dashboards. When this Prometheus system is integrated with Grafana, you can see very rich dashboards. You can see different types of graphs. So usually Prometheus is integrated with Grafana, and both of them together are used as monitoring stack. Like I told you, metrics, dashboard, and alerts, right? Grafana is very rich in dashboards. So it is combined with Prometheus very often so that they become very strong monitoring stack. Let's try to install Prometheus, right? Before we learn anything more about Prometheus, like before I explain what is exporters, what is this metrics endpoint, let's first install Prometheus, right? Because we have been learning a lot of theory. Before we cover some more theory part, let's install it. So you need a Kubernetes cluster. You can also do it on your Minikube or on your micro K8s kind, whatever you are using. I'm using a EKS cluster, which is a production like environment. And throughout this, I would be using EKS only because I wanted to give you a feel of real-time environment. So let me log into my AWS. Perfect. So I have signed into my AWS account, and let me go to the EKS service. You can see I have a Kubernetes cluster. If you also want to create a similar Kubernetes cluster, make sure you delete it after using. But if you go down, you can find the commands how to create EKS cluster. First, create a cluster, associate the OIDC provider with it, and then associate a node group. Why do you need OIDC provider? Maybe for today's video, it is not required. But when your Prometheus want to communicate, or the Prometheus application within the Kubernetes cluster wants to communicate with any other AWS services, this OIDC provider is important. It connects the Kubernetes service account with the IAM roles or the IAM policies in your AWS account. Okay, so we have done that. Now let's head towards installing Prometheus. So I will take my terminal. I hope I have Helm installed on my terminal. If not, I would do it. So let's fire this command. Okay, I already have Helm. If you don't have Helm, please install Helm and run these commands, which are used to add the Helm repositories for Prometheus. Now that we have, let's create a namespace for monitoring, where we are going to install Prometheus and Grafana. Okay, clone this repository because you have all the files in the repository. So what I'm going to do is git clone the observability 0 to hero and go to the repository in your local, then switch to the day2 folder. So in the day2 folder, once you go there, run the Helm command using this custom file that I have passed. Okay, Abhishek, why are you passing this custom file? So if you look at this file, which I'm passing to the Helm command, here I'm just asking it to enable the alert manager, which is for firing the alerts in our future videos. Of course, we will not fire any alert in this class, but I'm explaining Prometheus that, okay, along with your default components, if you see the default components of Prometheus, it comes with Prometheus server, retrieval, time series database, and HTTP server. But I am also installing the alert manager, which is a custom part. Perfect. So let's go back. Let's see if the alert manager and okay, I did not press on enter. So the Helm installation is under process. Okay, looks like Prometheus is installed. Let's run these commands to see. So in the namespace called monitoring, I'm just looking out for pods. So I can see the kube state metrics is installed. I will tell what is kube state metrics and node exporter as I promised. And the Prometheus is also installed. Okay. So we have the Prometheus related things running. Next, we will try to access the Prometheus UI. After that, we will understand what is node exporter and kube state metrics. So let's use the port forwarding mechanism. Perfect. So the port is forwarded. Let's also forward the port of Grafana. If you're wondering how Prometheus is already installed and Grafana is also installed, in this particular command where we are using this Helm chart, right? This is also installing Prometheus as well as Grafana. Okay, I have used the kubectl port forward command. Otherwise, I have to use ingress. And let me take another tab, new tab with the same profile. And here I will expose Grafana. I will do the port forwarding for Grafana. And let me take another tab and do that for alert manager as well, so that we can check all of these things at once. Everything is installed or not. Okay, so we have forwarded all the ports. So go back and let's try to access one of these. Let's start with Prometheus. So because I have done port forwarding, take your browser, paste it. You will see the Prometheus user interface. Again, I am not using ingress. What I am doing is I am using the kubectl port forward command. It is a port forwarding mechanism. We will use ingress in the later videos, but today it's the first class. So instead of creating three ingresses and ingress controller confusing you, I am using kubectl port forward. Okay, so you have Prometheus. Similarly, let's try to access Grafana as well. So copy this command, take your browser and paste it. So for Grafana, it will ask you for the password. If you go to the document, I think we have the password here. Once Grafana is, yeah, the password is prom operator. Okay, in the Grafana, provide the username. So let's provide the username as admin and password as prom-operator. Okay, so the login is successful. So we can see the Grafana dashboard as well. Perfect. Finally, let's also try to assign the, access the alert manager. So again, take a browser and 9093. So we have the alert manager as well. So we have installed all of them on the Kubernetes cluster. This is what you would exactly do for installing Prometheus, Grafana, and Alert Manager in your organization as well. On the EKS cluster, you would use the same Helm chart, same configuration. Only thing is that instead of using kubectl port forward, the command that we have used here, the port forward, you would use an ingress resource and ingress controller. We will also do that in the next videos. But for now, we have covered the installation of Prometheus, Grafana, and Alert Manager. If you go to Grafana, you can see here that there is a dashboard section where you can see some default dashboards already. We will cover that in tomorrow's video. What are the dashboards? How to use these dashboards? How to customize the dashboards? All that will be covered in the next class. Then you can also see the alerting rule configuration that I have mentioned. And you can go to the connection section, add a new connection, and here search for Prometheus. PRO, right? So you can see the Prometheus data source. And what you need to do is just provide your Prometheus URL, right? After providing that, this Grafana instance gets connected to the Prometheus. Of course, right now, we don't have a lot of metrics. So we will see the connection in the next class. How is it connected and how you can see the dashboards in Grafana. Okay, now let's move towards the final part and understand, okay, Abhishek, how does Prometheus scrape a lot of metrics? Because I told in the example that when you have a application, you have lot of things related to the application. You have the AWS infrastructure that needs to be monitored. You have the Kubernetes cluster that needs to be monitored, and also the application that needs to be monitored. So how one Prometheus can take care of all of those things? So you need to understand there is a concept in the Prometheus called as exporters. So these exporters are nothing but add-ons or plugins you can understand. So along with the Prometheus installation, if you install these exporters, like each exporter can take care of one thing. For example, you have a node exporter in Prometheus, which is an add-on or a plugin. So this node exporter, in the installation that we have done, we have also covered that. So if you just search for kubectl get pods -n monitoring, you can see we have the node exporter already installed, right? These ones. So it is a very common thing. That's why the default Helm chart installs node exporter. And what this node exporter can do is it can get the node related metrics. So it can continuously pull the node related metrics. What this node exporter does, it goes to each node of your Kubernetes cluster or each virtual machine of your Kubernetes cluster, and it pulls information like from the proc files, it can get the CPU utilization, or from the system, it can get the CPU utilization. So every minute, it will pull this information from the nodes of your AWS or Kubernetes cluster, and it stores these metrics. So the node exporter can give you the CPU related metrics, the memory related metrics, the disk utilization related metrics. It will store all of these things, and Prometheus will pull these metrics, right? So now Prometheus got the metrics related to your nodes. Similarly, there is another exporter called as kube state metrics. So this is another exporter, kube state metrics. And what this kube state metrics does is it will get all the information from your Kubernetes API server, right? So from the Kubernetes API server, it can get all the information such as the pod status, the deployment status, how many times your pod crashed, how many Kubernetes events your pod has omitted, everything that you can get from the Kube API server. This kube state metrics, which is another exporter, add-on, or plugin, will collect all this information as metrics, and Prometheus will scrape the metrics or pull the metrics from kube state metrics. Again, kube state metrics is also installed in the default installation. If you see here, kube state metrics is also available. So these are the two primary things. The Prometheus installation relies on the node exporter for exporting the information or scraping the information from the nodes. Along with that, it relies on kube state metrics to get any information of the resources on the Kubernetes cluster, such as pods, config maps, secrets, anything. It scrapes this information from kube state metrics. How kube state metrics gets this information? It will always talk to the API server. How node exporter gets this information? It will communicate with the virtual machines or the nodes and reads the system files of the nodes, where CPU information is recorded, where memory information is recorded. Okay, we got the infrastructure level metrics, we got the Kubernetes level metrics. How about application level metrics? Like I was giving example about HTTP requests, or I was giving example about user level signups, user level deactivation metrics, or how many times a user performed a specific activity on your application. To get that, the developers of the application should write something called as metrics server. So just like how you have /login page, /logout page, developers should also write the metrics API, which is /metrics endpoint, and Prometheus using the service discovery mechanism. So you can tell Prometheus that, okay, these are the 50 applications from where you need to scrape the /metrics endpoint. So depending upon the applications that you provide, Prometheus can scrape the /metrics endpoint of your payments application, catalogs application, any applications that you have. So these are three primary things that is used by every organization. Apart from that, there are multiple other exporters for Prometheus. It has a database exporter and multiple other, but these are the three primary things. Node exporter, for your infrastructure, the node infrastructure, kube state metrics for your Kubernetes related information, and slash metrics endpoint for your application level metrics. Now the final question, Abhishek, are there any competitors to Prometheus? Yes, there are so many competitors. Like there is Nagios, which is also open source, a competitor of Prometheus. You have InfluxDB. There is something called as Graphite. So there are so many competitors, open source and also closed source. But the reason why Prometheus is very, very strong, or why it is very commonly used, is it is a CNCF project. In fact, it is the second CNCF project after Kubernetes. So it has a very strong community, and lot of closed source tools or lot of companies who are building observability tools are using Prometheus as monitoring instead of writing their own monitoring servers or creating monitoring from scratch, right? So this is the information for today's video. Make sure you go through the notes, and also you can take a look at the Prometheus official documentation if you need more information. What we will do in the next class, we will learn more about PromQL. We will learn how to get the metrics information from kube state metrics, from the node exporter, and play with those metrics on the Grafana dashboard. So we will see the graphs, representation, and everything. Thank you so much for watching today's video. I hope it is informative. See you all. Take care. Bye-bye. Hello everyone. My name is Abhishek and welcome back to my channel. Today is episode 3 of Observability Zero to Hero series. Till now, we have completed 2 episodes in this series, starting with day 1, where we have learned about the introduction to observability, basically the fundamentals of observability, such as what is observability, what are the 3 pillars of observability. We also learned the difference between monitoring and observability, how they are different from each other, and some important basic information that is required for you to get started with observability. Then in day 2, which is the last class, we learned about metrics and monitoring. So we went in detail about metrics and monitoring. We took a real world example to understand metrics and monitoring. Along with that, we also understood the differences between metrics and monitoring. Then we learned about a popular monitoring system in the space of Kubernetes, that is Prometheus. We learned the basic architecture of Prometheus. We learned how to install and configure Prometheus on an EKS cluster. And we also saw how to install and configure the Prometheus stack, which is Alert Manager as well as Grafana. Towards the end of the video, we learned how to access them from your browser. Today in day 3, what we will do is we will learn more about the Prometheus architecture, but practically. So we will see how Prometheus is scraping the metrics practically. So we will see how it collects information from node exporter, how it collects information from kube state metrics and other sources. We will also learn about PromQL, which is Prometheus query language. What is it? How can you write basic queries in Prometheus? So this video is going to be very interesting because we are going to play with Prometheus, we are going to play with Grafana, and we are going to see a lot of metrics live in this video. Make sure you watch it till the end. And as I keep saying, after watching the video, please go through the notes. We have put a lot of efforts in preparing the notes to make sure after watching this video, These notes should serve as a revision material for you people. And everything that I talk in the video will definitely be covered in the notes. Sometimes you might also find much more in the notes. So spend 10 to 15 minutes and revise the video. Okay, now let's go to the whiteboard and start from Prometheus architecture before we log into the system and see those metrics. What we learned was Prometheus is a monitoring tool, and the primary responsibility of Prometheus is to scrape the metrics. And there are some important sources from which it scrapes the metrics, such as the node exporter, which is collecting information. What does a node exporter do? It will run on your Kubernetes cluster as a pod, and it will collect information from all of your Kubernetes nodes, such as the CPU information of your nodes, the memory information of your nodes, from the system files of your nodes, or by running some programs. So node exporter is typically getting information of your Kubernetes nodes, which are the infrastructure part on your cloud. If you are running Kubernetes cluster on a AWS environment, these are typically the virtual machines or the EC2 instances. So this is what node exporter is doing. It is getting all the information from the nodes. Then another primary source where Prometheus gets the information, or Prometheus scrapes the information, pulls the information, is from kube state metrics. So kube state metrics is very, very important. Again, this is a type of exporter or a program or a plugin that is running on your Kubernetes cluster as a pod, and it talks to the API server of your Kubernetes cluster. And it literally gets a lot of information from your Kubernetes cluster, such as your pod status, deployment status, replica sets, services, config maps, custom resources, such as validating webhook. Literally, it gets so much information from your Kubernetes cluster on a periodic basis. So it gets the metrics and keeps those metrics with itself. Okay. And then the custom metrics. Another primary source from where Prometheus scrapes the metrics is the custom metrics which are related to your application, such as the time your application is taking to process a HTTP request, or number of users that have created an account with your application over the period of 24 hours or 15 minutes or one week. You can get such information from custom metrics. We will see how developers will write these custom metrics in day 4, that is tomorrow. We call this as instrumentation of metrics. We will see how can you do that using Open Telemetry, other sources, but this is more from developer point of view. But still we will learn how developers will write these custom metrics and how Prometheus collects it. So these are primary sources from where Prometheus scrapes the metrics. We will see practically, as I told you at the beginning of the video, how node exporter is collecting this information, how kube state metrics is collecting this information. Wait for a while. It is important to make sure your fundamentals are clear. So Prometheus scrapes these metrics and stores them in a time series database. If Prometheus or on your Kubernetes cluster, if node exporter is not installed, or if kube state metrics is not installed, literally the amount of metrics that Prometheus can scrape goes down. Without these things, Prometheus cannot gather a lot of information because these are pillars or sources of Prometheus. And overall, in your organization, you might have other exporters as well. Like there can be a database exporter. If you are using let's say MySQL dominantly, and you want to collect metrics about your MySQL database, the performance of your MySQL, then you can install something called as MySQL exporter on your Kubernetes cluster, and that will collect information from your MySQL. So as a DevOps engineer, as an SRE engineer, you have so many things that are already done for you. Like you just need to know how to run MySQL exporter as a pod, as a service on your Kubernetes cluster. It is taking care of a lot of things. If you just tell it the IP address of your MySQL, it will continuously talk to the MySQL and get the information. Similarly, if you know how to install Node Exporter, most of your job is done because Node Exporter is getting the information. And what Prometheus is doing, it is storing all of that in a time series database. Typically, time series database is nothing but at this particular timestamp, what are the values of your metrics? So time series database is storing on a periodic basis where it knows the time. That's it. Because in this case, time is very important, right? In a traditional database, you will just put the key value pairs. That is name value or employee name. What is the name of the employee? But in Prometheus, the time is also very important. At 10 o'clock, what are the metrics? So in the time series database, you store the metrics, maybe as key value pairs. But along with that, you also record the time of that particular metrics. That's why it is called as time series database. Now, if Prometheus does all of these things and just keeps all of that information with Prometheus, how as an end user or how as a DevOps engineer or site reliability engineer, how you can know what information Prometheus has? So that's why there is something called as PromQL, which is Prometheus query language, using which you can talk to a component of Prometheus, which is the HTTP server. So Prometheus has a HTTP server using which, as a user, you can write the PromQL queries. For a database, you might be writing a SQL query. Similarly, for Prometheus, to get the information from time series database, you are writing the PromQL query, Prometheus query language. And as you write the PromQL language, you can get the required output maybe in the graph format or in the raw format, whatever you would like to prefer. Because this information is very raw. Maybe sometimes you might not be even able to read it because you have tons of information. Using PromQL, you can aggregate it, you can get it for a set defined timeline, and you can look it in the graph format. And additionally, we learned that there is also something called as alert manager, where if you feel a particular metrics is exceeding your threshold, if you feel that the CPU of the nodes is too abnormal, you can set an alert and you can fire that alert to a particular Slack channel or email address, email alias. So this is the primary architecture of Prometheus. Now let's see in practice that, okay, we discussed all of these things, but let's see if Node Exporter is actually collecting the information. Abhishek, you said Node Exporter collects the information. Can we see that? For sure. First, let's take our Kubernetes cluster. This is where we stopped the last video, right? Where we have used the kubectl port forward and we have exposed Prometheus, Grafana service, as well as alert manager service. Now, why did we use kubectl port forward? Because different people might be using different Kubernetes clusters, and their ingress configuration can also be different. So kubectl port forward works unanimously in any Kubernetes cluster. That's why I exposed these services using port forward and showed you how to access the user interface. And I also promised that I will share the ingress configuration. So if you're on AWS, so here you have the ingress resource. Just deploy this ingress resource and using this file, install the ALB controller, and you don't have to do this kubectl port forwarding. You can directly access them using the load balancer IP address as well as the endpoint. But I will not go into that in this video because it will confuse people. I have the steps for you. Just download that steps or just execute that steps on your EKS cluster and you will get it done. But because different people might have different Kubernetes cluster, let's continue with the kubectl port forward and expose all of the services. Abhishek, I did not follow day 2. What are you talking about? Just go to the day 2 folder or watch the video. In the README file, you have the commands to expose Prometheus, Grafana, as well as Alert Manager and use it on your browser. Okay. Now, again, if we go to the terminal and if you run kubectl get pods in the monitoring namespace, I'm not sure if you have observed it, but when you are installing the Prometheus stack, kube-prometheus-stack, along with Alert Manager, along with Grafana, and along with Prometheus, what the the kube-prometheus-stack installs for you is also the node exporter as well as the kube state metrics. As I told you, it is very, very important to have the node exporter and kube state metrics on your Kubernetes cluster. Without this, Prometheus cannot get a lot of information. It primarily relies on node exporter as well as kube state metrics to scrape the metrics. And you can see there are 2 instances of the node exporter, but only 1 instance or only 1 pod of kube state metrics. Do you know why? Because node exporter runs as a daemon set. It has to collect information from each and every node individually. So node exporter runs as a daemon set, and kube state metrics, it has to talk to the API server. It doesn't matter on which node it is. It can make an API call to the API server. So there is only 1 replica of it. Okay, perfect. Now, if we do kubectl get svc, I want to get the IP address of the node exporter service so that I can make a request and show you how it is collecting the information. So this is the node exporter here, and the service is running as a cluster IP address, which is a very good practice. So this is the IP address and port is 9100. It is running as cluster IP. So obviously you cannot access it on your browser or outside your Kubernetes cluster. So what we will do is we will take our AWS account because this Kubernetes cluster is running on AWS. I will go to the EC2 instances. So these are the nodes of my Kubernetes cluster. I will go to one of the nodes and click on the connect button. Click on the session manager. Abhishek, I am doing this on a minikube cluster. What should I do? Just run minikube SSH and you will be inside the node of your minikube cluster. It is very simple. If you have EKS cluster, then you need to go to the EC2 instance or log into your node. Run curl followed by the IP address of your node exporter followed by the port of your node exporter, which is 9100. Let's do that. 9100 colon 9100 slash metrics. And see, this is the information that your node exporter is collecting periodically. So you can see the amount of information that the node exporter is collecting. It gets the CPU, it gets the memory, it gets the programs that are running on your node. Let's say how many threads of an application are running on your node, how many Go routines, if you're using Go programming language, all of them are collected using the node exporter. And it is keeping all this information. Where is it keeping? On the slash metrics endpoint. As I told you, Prometheus gets the information from node exporter. But how does it get? In node exporter, there will be an endpoint called slash metrics, and on slash metrics, node exporter will return this particular output. So I use the curl command, curl followed by the IP address and port of node exporter, followed by slash metrics, and it gave me all this information. And this information, if you see, it is in the format that Prometheus understands. So this is the purpose of an exporter. Similarly, if you like, let's use the kube state metrics exporter, right? Again, you will have kube state metrics on your Kubernetes cluster, just like how you have the node exporter. This is the IP address of your kube state metrics. Port is 8080. So again, if we go to the session manager, curl port 8080 slash metrics. See, this is the complete information of your Kubernetes cluster. The validating webhook configuration, literally the resource version of your validating webhook on a particular namespace, or you want to see the pod related information. How many times your container crashed? We can see that. For example, let's grep on the containers. Grep container. So on the kube state metrics, which is collecting the metrics from API server, I will use the grep command to get the container information. And again, there are a lot of things. So let's also do grep on, let's say, restart. So you can see how many times the init container is restarting. Which init container? All the init containers. It gets information of total init containers on your Kubernetes cluster, how many times they are restarting, which one is restarting, at what time is it restarting. It collects all that information. Just like init container, sidecar container. Again, your regular container. See, this is the regular container. Kube pod container status restart total. So this is the metric. And in this metric, you can use a particular label. So this is the label where you can see in which namespace you want, or what is the name of the pod. You can do all that. Let's take this as an example and let's play with it. Okay, so Prometheus now has gathered a lot of information, right? As we saw from node exporter, it gathered a lot of information. From kube state metrics, it gathered a lot of information. Can it actually return these values on our query? Like, is this information saving in the time series database? Let's see in real time. For that, we just need the IP address of Prometheus. So using port forward, we exposed it on this particular IP address. So let's go to the browser and paste it. Perfect. My Prometheus is running. Now I will take that metric that we saw. Okay. Kube pod container status restarts total. And what is this metric doing? It is basically telling how many times the containers are restarting. All the containers in all the namespaces. Let's run this query. Okay. So these are different containers and it explains how many times the containers are restarting. Abhishek, it's hard to read this. What to do? The graph option. So here you have graph where you can select a particular container. Right now, none of the containers are restarted. That's why you are not seeing anything. Let's fine tune the query. And what I'm going to do, this is your first query, right? So I'm going to improvise the query. To improvise the query, along with the metric that you have copied, in the label section, that is in the square curly brackets, just say namespace is equals to, let's use the default namespace and click on execute. It has written nothing because if you do kubectl get pods, let's do kubectl get pods on the default namespace, and literally there is nothing. That's why the Prometheus is saying, okay, this is the graph. There is nothing, so there is no graph. Abhishek, let's install a pod that gets crashed. Okay. So I want to see practically if Prometheus is working or not. And if kube state metrics is collecting the information and giving it to Prometheus or not. So let's do one thing. We will install a pod that will always crash. So I have an example command, or let's write this command. So this is a kubectl command. Kubectl run busybox crash. So basically a pod that will always crash. It will go into crash loop back off, because in the command argument, I said exit one. That means it will keep crashing. And I want to see that on the Prometheus. So that's why I gave this pod that will always crash. So let's put it. And if you do kubectl get pods, it crashed once. Let's do again. Okay, it crashed only once till now in the last 10 seconds. In the 12 seconds, it only crashed once because it is going into the crash loop back off. Now you can see the restarts are 2. That means it crashed twice in the last 1 minute. Let's see if you can see that on Prometheus. Execute the query. Okay, now you can see that there is a graph, and if you see towards the end, there is something here. Why? Because the graph is shown for 1 hour. Let's just change it to 1 minute, and you can see there is a graph which explains, okay, there is one crash here, there is another crash here, and another crash here. So if someone does not have access to your Kubernetes cluster, you can create a dashboard for them using this query, and you can tell them, okay, do you want the crashes of the pods? Run this query. Do you want on default namespace? This is the label. Like this is the query for default namespace. Do you want for all namespaces? Just remove this. And you can literally get for all namespaces. So this is for the busybox pod, and just change the pod here. This is for alert manager pod. This is for the EKS node agent pod. This is for core DNS pod. So they can see the graphs for each pods if you have empty in the brackets, but you can add labels and selector where you can say namespace is equals to default, and you can see about a particular pod. Sometimes your development team will ask, okay, Abhishek, can you set up Prometheus and set up a particular query so that every day we can see how many times our pod is crashing in 1 minute time, or if you just change it to 24 hours, something like this, right? So you can also see in 1 day how many times the pod is crashed. It is not available for 1 day. That's why the result query is empty. But sometimes as you have a established Kubernetes cluster, or you have a proper dev team which is running Kubernetes cluster every day, then they might also want to see it for 24 hours. Perfect. So this is how you see the particular query and on the Prometheus. Now let's try to understand what this query did, like just for a couple of minutes. So as soon as you created a pod, okay, who receives the information? Kube API server. And then it will talk to the scheduler. Then it will talk to the kubelet. Kubelet installs the pod. Let's not go there. That is not required. So as you have used the kubectl run command to create a pod, instruction went to the Kube API server. And there is someone who is continuously looking at the Kube API server. Who is it? Kube state metrics. So kube state metrics was continuously looking at the API server, and it got the information that, okay, some pod is installed. Now I will get the metrics about the pod. One of the metrics that I am interested is total restarts. Okay. And I will collect this information and I will keep it on the slash metrics endpoint in the format that Prometheus understands, right? So that when Prometheus, how did Prometheus come to know? That is what I'm trying to explain. So now Prometheus is continuously watching kube state metrics on the slash metrics endpoint. It is getting the information from API server. And now when as a user, when you are firing the PromQL query, you got the information. So many things happen within seconds of time. And as an end user, it might be your manager who might be looking at this graphs, or it can be your testing team. They can get the information about the pod crashes. There are thousands of metrics. This is one example that I've taken. If you go back and if you look at the session manager, the reason why I was showing you the session manager is the kube state metrics itself can collect so much information. We just looked at one particular metrics. Let's see another one. For example, we looked at the pod container restarts, right? Let's look at the init container restarts. So again, you just go here and just remove this command, put init containers without a namespace. So copy the metrics and execute the command here. Okay, there are no init containers on the cluster. That's why you're not seeing anything. You can do for the nodes. Oh, sorry, the command is wrong. Okay, so these are the different init containers on the cluster, and you can see the number of restarts for them. Abhishek, but how will I know the total number of metrics? Like which are important to me, which are important for my organization? You need to do the research. There is absolutely no other option. There are some standard things like pod crashes, which is a standard thing. Or when I show you the Grafana, you will understand much more because Grafana has better visualization than Prometheus. That's why Grafana is very popular. We will get to Grafana. Right now, let's focus here. So what you can do is you can also make use of the Prometheus auto completion, where if you type cube, it will tell you different information that it can give you, like cube config map that is created. Execute. Okay, it shows how many number of config maps are created. You can also do it for a particular namespace. So your manager asked, Abhishek, tell me how many config maps are created in the kube system namespace in last 10 minutes or in the last 2 days. Okay, so let's give the kube system namespace and click on the execute. So you can see the number of config maps that are available in the kube system namespace. And you can also see for period of, let's say 30 minutes, for the period of 5 days. You can see different lines here, which are representing different config maps. That is cube config map created for, this is for a particular config map, which is AWS authentication. This is another config map. You can get the information about on which node the config map is created. You can see multiple things like if the config map is deleted and recreated, all that things. So just explore this auto completion feature in Prometheus. And I would also recommend just go to your session manager or your node and see what are the different things that your kube state metrics as well as the node exporter is collecting. Do you need to know everything? Definitely not required. It is not your business to know all the metrics that kube state metrics is collecting. As you have requirement in your organization, you will use certain metrics. For your interviews, you can say the common metrics like how many times the pod has crashed, how many times the config maps are created over a certain time. how many secrets are there in your Kubernetes cluster, or it can be like the CPU, memory, disk utilization, the HTTP request, users created. These kind of things you can keep in mind and you can tell in the interviews. Now, Abhishek, if Prometheus is doing all these things for me, what is the purpose of Grafana? Prometheus has basic user interface and it can show you very basic graphs. It is a monitoring tool. It can do three things: the metrics collection, it can do the visualization, and it can also help you with the alerts. You can see here, you can also set up alerts with Prometheus. We will cover this. Right now, we are focusing more on metrics. So it can do the alerting, it can do the graphing, and it is also scraping the metrics. So it is eligible to be called as a monitoring system. It is doing three things. Now the point is, what is reason for Grafana? Grafana, like, let me move to the whiteboard. So you can understand Grafana as the better visualization or a better dashboard platform. And the good thing about Grafana is that tomorrow, if your organization is moving away from Prometheus to, let's say, Nagios, or to, let's say, Grafana, Graphite. Grafana supports all of those data sources. To your management, you can say, so this is your Grafana instance. Like, you can give it to your manager, your director. Say that this is the Grafana. These are your dashboards. I have configured the queries. So just go to the dashboard if you want to see total pod restarts, total secrets created. Go to Grafana, click on this button, you get the information. So it is independent of Prometheus. Second thing is, in couple of minutes, you will see that it has better visualization because it is predominantly created as a dashboard application or a visualization application. Grafana is not a monitoring tool. It is a visualization platform or a dashboard platform. Second thing is, in Grafana, you can also set up your authentication and authorization. You can see Prometheus here. There is no authentication authorization mechanism. With Grafana, what you can do is you can integrate it with your maybe the IAM, or you can integrate it with your SSO, so that you can say only my managers should see these particular dashboards, or management. So my management can have the view access on the dashboards. My DevOps team can create particular dashboards. Like, they can delete a dashboard, they can create a dashboard, or they can update the query of the dashboard. My dev team has certain permissions. My QA team has certain permissions. So along with better visualization platform, also support for other data sources or monitoring tools like Prometheus, it also supports the authentication and authorization. Abhishek, can we see that? For sure. Again, go to the terminal, see what is the command to access Grafana. Okay, this is the IP address and port to access Grafana. We have already accessed it before. That's why I got this page. Otherwise, the username is admin and the password is prom-operator. You can get this information from the docs or watch the previous video. So this is a Grafana UI where, like I told you, you have logged in as admin, but if you go to the administrator tab, you can integrate, you can create users, you can do the authentication with your SSO, and then you can define who is admin, who is dev, who is etc. So in Grafana, you already have dashboards. So in Prometheus, you were writing some queries, right? And you are executing the queries to get the graphs. But what Grafana has done is it has created some predefined graphs. So these graphs comes with some queries which are out of the box on Grafana dashboard. So as a DevOps engineer, as site reliability engineer, what are the things that you use on your day-to-day basis are already set up on Grafana. For example, you can see the node related information. For example, this is the pods that are on the default namespace. Abhishek, why am I not seeing any data? Because the data source that you have selected is default. Click on the drop down and select Prometheus and click on the default. Just you will start seeing. So you can see the information here. There is one pod called as busybox and it is occupying 0.00006 of the CPU on the node because it's just a dummy pod, right? So that's why it is occupying very less CPU. So these dashboards are already created for you. If you are using Prometheus, you should have written that query. That is the CPU utilization of the pod in the default namespace. Let's go to another namespace. For example, kube system. You can see multiple pods are running here. And if you click on a particular pod, you will get the graph of that particular pod as well. Like let's click on this particular pod and you got the memory utilization of the pod named AWS node in the kube system namespace. And you can also do the filter just like how we were doing on Prometheus. Change it for, let's say, 30 seconds. Sorry, that was auto refresh. You can change the timeline of this particular graph for, you are seeing it for last 1 hour, 10:55 to 11:55. You can change it to see for 30 minutes. You can change it to see for 1 day, 2 days, 10 days. So Grafana has automated some things for you. These are the default dashboards on Grafana, such as your namespace, pod resource utilization, your, let's say, the persistent volumes that you have on your Kubernetes cluster, the commonly used things. But I want to create additional dashboards. Abhishek, the pod restarts is not available here. What we tried on Prometheus, I don't see it here in Grafana. How to create the dashboard and give it to my management? So what you can do is click on the new button and click on the dashboard. So do you want to import a default dashboard? No, I want to create my own dashboard. And what should be the data source? Grafana has already identified Prometheus data source on your cluster. So you don't have to do anything. Just select Prometheus. Now here you can write the query. So take the Prometheus query. What was that? So this was the query, right? If I copy it, kube pod, not for the init container, I want it for the containers. So kube pod container status restart total, and I wanted it in the namespace is equals to default. Run query. Okay, I got this dashboard. The pod got crashed 8 times. And if I just change it to 5 minutes, I can see better in what timestamps the pod got crashed. And let's say do it 30 minutes. You can see very clearly. So it got crashed at 17:12. Then it got crashed at 17:13, 14, 17. So because it is crash loop backoff, the time is increasing. If you remember the crash loop backoff concept in Kubernetes, so what crash loop backoff does is initially it crashes in the first 1 minute, then it will do the loop with a backoff. That is, then it will crash in 3 minutes, then it will crash in 5 minutes, then it will crash in 7 minutes, like that. That is crash loop backoff. So you can get this information. If this is important for your organization, you can save this dashboard and see now the dashboard is saved. As soon as your manager logs in, they can see this dashboard every day. Maybe towards the end of the day, they can look at this dashboard. Like that, you can create some 10 dashboards, 15 dashboards, 20 dashboards, and share it with your management. You can also give the name for your dashboard and you can just save it. Abhishek, apart from Prometheus, I want to add, let's say, more. Like I want to add Nagios, or I want to add Graphite, InfluxDB. In the connection section, go to the data sources. These are the default data sources that you have. Sorry. These are the default data sources that you have. Click on add data source. Like you wanted to select InfluxDB, select it, give the address of your InfluxDB. Like provide the URL, all the things that are required for the configuration. Prometheus was auto-detected. That's why you did not have to do much. So this was the service address of the Prometheus on your Kubernetes cluster. There was no authentication. That's why you accessed it out of the box. And all the configuration was set to default. And these are the dashboards related to Prometheus only. Like that, you can add multiple data sources in Grafana. So even if you are not using Grafana for your Prometheus, you can use it with InfluxDB, let's say Nagios, let's say Graphite and other things. I think we have covered the required things on the Grafana dashboard. This is how it is used. Now, what are the things that are left for us to learn? That is, in tomorrow's class, what are we going to learn? One important concept that we have not covered till now is the custom metrics. We used the node exporter, we used kube state metrics. What about this custom metrics? Abhishek, you were telling HTTP requests, you were telling the number of logins, how developer will write these custom metrics. So in tomorrow's class, we will focus about custom metrics. What are the type of custom metrics, or overall, what are the type of metrics? Like in Prometheus, you have something called as the gauges, you have counters, you have summary and histogram. Now, what are these things? So when a developer is instrumenting the metrics, or a DevOps engineer is instrumenting the metrics, when they are writing the metrics, they can define the metrics type as the following. We will learn in tomorrow's class. So how to instrument the custom metrics, we will learn this. Then in your Kubernetes, there will be hundreds of pods, there will be hundreds of services. Should Prometheus be looking at the custom metrics for all the services and all the pods? No. You might have 10,000 services on your Kubernetes cluster. If Prometheus will make API calls to all the 10,000 services on your Kubernetes cluster, literally your Prometheus will eat up your Kubernetes cluster, because the number of calls have increased. So the CPU memory utilization will go high. For that, there is a concept in Prometheus called service monitor. This service monitor will tell Prometheus which services to look for, which applications on your Kubernetes cluster are exposing the slash metrics. For example, let's say you have deployed Amazon on your Kubernetes cluster, or e-commerce on your Kubernetes cluster, and there is maybe slash login endpoint, there is logout endpoint, there is, let's say, payments, transactions, different services, out of which only login and payments are giving the metrics to you, or only these are the services where your developer has instrumented the metrics. It can be using Open Telemetry or any other thing. So you will create a service monitor which will tell Prometheus that, okay, only watch for login slash metrics, payment slash metrics, because only they will give you the metrics, and store that metrics in the time series database. Right? So we will cover what are custom metrics, what are the type of metrics, so that developers can instrument those metrics in their code. We will learn about service monitor. All this practically in tomorrow's class. We will do a demonstration as well. Right? So now your goal will be to go through the documentation, go through Prometheus, look at some metrics from kube state metrics and node exporter, and try to write the queries for them. And one thing that I forgot to tell you is, sorry, if you go to the README file, You can also see that there are some commands for aggregation of metrics. For example, if you do something called average, it can give you the average of the metrics that you have collected. These are useful in case of CPU utilization or memory utilization. For example, you want to get average memory usage grouped by different namespaces on your Kubernetes cluster. For that, you will use this called as average. Similarly, you can use sum. Mostly you will use sum and average because as a DevOps engineer, you might want to collect the sum of CPU utilization of pods in default namespace and Abhishek namespace. For that, you will write the query and you will just say sum. So go through the documentation. You will understand some of the aggregator functions, which are very simple, and you can get used to that. Also look at Grafana, right? These are your take backs from this session, and wait for the next session where we will learn about the custom metrics. Thank you so much for watching today's video. I hope you found it useful. See you all in the next video. Take care. Bye-bye.
Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 4 of Observability Zero to Hero series. Till now, we have completed 3 episodes in this series where we started with what is observability. We learned about metrics, monitoring, Prometheus, Grafana, and many other interesting things. In today's video, we will learn about instrumentation of custom metrics. We will learn what is instrumentation, why is it very important. Then we will see practically how metrics are instrumented using a Node.js application. And then we will learn about the alert manager configuration and how to fire alerts in real time using alert manager. This video is going to be very practical and informative. Make sure you watch it till the end. After watching the video, if you want to get the notes, you can go to the GitHub repository. Link is in the description. And just go to the day 4 folder. You can even find the source code of the application that I'm going to use in this series, in this particular video. And you can also get the README file where you can see the complete details that I'm explaining in the video. You can use it as revision material. Architecture diagrams are also provided. Okay, so let's start with what exactly is instrumentation. If you have followed this series, in the very first episode of this series, when I was introducing you all to observability or explaining what is observability, I mentioned observability is a collective responsibility. What does that mean? Let's say you have a very good DevOps or SRE team and they have built a robust observability stack. Let's say they have set up Prometheus for monitoring, they have set up Grafana for advanced dashboards, they have set up EFK stack for log aggregation, and they have set up Jaeger for dynamic tracing. Everything is set up and running, ready to use. But what if the applications in your organization, let's say you work for a e-commerce application where you have different types of services, if these applications are not omitting the metrics, or if logging is not done in these applications, or traces are not provided in the application. So if developers of this application are not giving you this information or giving the observability stack this information, what is the point? It doesn't matter if you have Prometheus, if you have Nagios, or if you have anything, if the instrumentation of metrics. So this process of writing the metrics in the application, or writing the logs in the application, or defining the traces in the application is called as instrumentation. And this is very, very important, because otherwise the setup that you have done, or the complete stack that you have set up, is of no use. Of course, you might say, but Abhishek, I can use some exporters, right? But exporters cannot get the information that is very specific to your application. For example, I want to see how many users have logged in to my application in the last 30 days, or how many of them have created an account in the last 30 days, or something like the latency specification, a specific latency specification of your application, or the HTTP request duration of a particular service. Exporters cannot get you accurate information about these things, because exporters are plugins. They are set to do a particular activity. For example, if you take a node exporter, it can get the information such as CPU or memory or the disk utilization of your Kubernetes nodes. Or let's say you have a MySQL exporter. It can get information from the database or metrics related to your database. But if you want to identify the traces, or if you want to put your application in the debug mode and get additional information about your application, or metrics related to your application, instrumentation plays the key role. Now it's up to your organization if this instrumentation is taken care by developers, platform engineers, SRE engineers. It depends from organization to organization. So if you assume that in your organization, instrumentation is taken care by developers, so it is their responsibility to provide all of this information, and it is the responsibility of DevOps and SRE engineers to set up all of these things and create dashboards, whatever is required, fire the alerts, all of them. Now, Abhishek, can we see an example like how developers instrument these metrics? For sure, we have a very good application. We are going to deploy it. We are also going to see it through the Prometheus UI. But before that, there is one simple concept that you need to understand. You don't have to master it if you are not instrumenting the metrics in your organization. Most of the times, DevOps engineers does not do that. But it is important to understand, just like how every programming language has data types. If you're using Python or even shell scripting to represent the data, you have different kinds of data types, right? You have strings, you have list, you have dictionary. Why do you have different types of data? Because not every data can be represented in a specific data type. Sometimes you need a string to represent, sometimes you need a list to represent the data, sometimes you need a dictionary to represent the data. Similarly, even when you look at metrics, there are metric types. Why? Because not every metric can be represented in the same metric type, just like your data types. So you have four popular metrics types, especially if you are using Prometheus. So the developers of the application can instrument the metrics using this four different metrics types. The first one is counter. Second one is gauge. Third one is histogram. And fourth one is summary. So, like I told you, if you are a developer or if you're doing the instrumentation, you need to know them in detail. Otherwise, you just need to understand what is the responsibility of each of them. Like, when do you need to use this data type? When do you need to use this? When do you need to use this and this? Let's understand that. So when you have a metric that is always incrementing, that is, the count of this matrix is always going high. For example, the logins in your application, if you want to see the number of logins or accounts created with the application in the last 30 days or over a particular period of time, this is always an incrementing number. Because if once the user has created an account, the account is created. You are tracking only the account created metrics. You are not tracking if the accounts are deactivated, if they have deleted the accounts. No, that is not the purpose. In the metrics, you are only seeing how many accounts are created, and that can never go down, right? So today, if it is one, it can either be one, or tomorrow it can be two, three, four, five, keeps on increasing. So such kind of metrics which are always increasing is called as the counter metrics, or that has to be represented in the counter metric type. Another example can be the number of HTTP requests received by your application. If the HTTP request is received, it is received, right? So that is always again an incrementing number. Now you have gauge. This can be incrementing as well as decrementing. So when you have a graph like this, unlike a counter, right? So this particular thing or this particular metrics which are incrementing and can be decremented as well should be represented in the gauge metric type. Abhishek, can you give some examples? Sure. Let's say you want to see the number of config maps or CPU utilization or memory utilization. These things can go up and come down. Maybe at 11 o'clock, the CPU utilization was 67. I'm just giving an example, 67%. And 11:15, it might be less, 50%. 11:20, it might be more. Again, it can be down. So when you have such information that you want to represent in the metrics, then the developers should record that information in the gauge metric type. If you are new to programming, you might find it difficult, but if you are already doing programming with any programming language or have the basic, I think this is very simple to understand. You need to know the nature of the metric. If the nature of the metric is always incrementing, go with the counter. If the nature of the metric is incrementing as well as decrementing, go with the gauge. Or if you're not worried about incrementing and decrementing, but if you need some bucket of information, then you should go with histogram. Abhishek, what is this bucket? I'll make it very simple. Let's say your manager asked you, what is the HTTP latency? Or you want to see that how many times the CPU utilization went below 50%. These kind of things should be recorded in the buckets. So if somebody is asking you, what is the HTTP request duration? Okay, let's take this as an example. Instead of taking too many, HTTP request duration. I'm not talking about the HTTP request number. I'm talking about HTTP request duration. If somebody is asking you, tell me how many times the HTTP request took less than 5 milliseconds, or how many times HTTP requests have taken more than 100 milliseconds. If you are using counter or gauge, how can you give this information? It's not possible, right? So that's why you create buckets, and you will say this bucket is for 5 milliseconds. This bucket is for 10 milliseconds. This bucket is for 100 milliseconds. And at 11 o'clock, let's assume your application got a HTTP request. And if it is taking 5 milliseconds, you will put that request in this bucket. Again, maybe at 3 o'clock, you got another request that took 5 milliseconds or less. Again, you will put this in bucket. So this way, you will record the information in buckets. 10 milliseconds, it will go to this bucket. 100 milliseconds, it will go to this bucket. And now when somebody asks you, give the information of 5 milliseconds, you will give this bucket back to them, or this bucket back to them, this bucket back to them, right? This is how you make use of buckets so that you can track information about duration or latency, these kind of things. Now, summary is exactly same as histogram, but at this point, I will not go into the details of summary because it might confuse the beginners. If you want that, it is available in the documentation. And also, I will cover summary as we progress in the series. We have a dedicated video for instrumentation that is using Open Telemetry. During that time, I will talk about summary. Now we are talking about instrumentation of metrics using Prometheus. So this particular knowledge or this particular basics is good enough. Now, Abhishek, can we see an example? Like you have mentioned, a demo application? For sure. Let's go to the GitHub repository, click on the dot so that we get a Visual Studio interface. Go to the day 4 and let's go to the application section. Click on the service A. You don't need to understand this application. It's a very simple application which returns, which has multiple APIs. I'm going to show you that. So if you go to the index.js, okay, so there is service A that is talking to service B for creating a simple API, but our focus is metrics. If you go to index.js, I have taken a Node.js application, and here you can see how metrics are instrumented. First you need to do is use something called as Prometheus client, or if you don't want to use Prometheus specifically, Abhishek, I want to use something which is a standard, like tomorrow I might use something else. Tomorrow from Prometheus, I want to move somewhere else. You can also do something called as Open Telemetry. We will get there. For now, you need to instantiate a Prometheus client. And using this Prometheus client, you will declare the metric types. For example, here we have defined the first metric type where using the prom client, we are saying, okay, I want to define a counter. So the metric type is counter, a new metric type. What is that name of that metric type? Counter. But what is the name of the metric? It is HTTP request total. Can HTTP request total can ever go down? Definitely not. If a HTTP request is received, it is received. So the count cannot go down. That's why HTTP request total is always an incrementing number. That's why the developer will record this in a metric type called as counter. Okay. So some description is also provided. What does it mean and all? And for us to query this specific metric type of this specific application, you need labels, right? So we were using labels from Prometheus UI, and that labels are also defined in the definition. Then another example, like I said, the HTTP request duration seconds, right? The same example that we have taken here, HTTP request duration, it has to be done in buckets. That's why the developer will define a metric type called as histogram and see the different types of buckets that are created. So this is important. One bucket for 0.5 milliseconds, okay, seconds, one bucket for 0.5 seconds, 1 second, 5 seconds, and 10 seconds. So you have different buckets. If somebody is asking you about 10 seconds bucket, give this information or give this bucket. So buckets are created for metrics of types like HTTP request duration. Initially, you might be confused like, okay, this should go to histogram, or this should go to summary, or this should go to counter. But as you keep writing the metrics, like I write a lot of metrics for the application, the metric server. So probably it is easy for me. But for beginners, you will take some time understanding like what type of metric type that I have to use. You will also face this problem if you are new to programming. Should I go to list or should I go to a dictionary type, right? As you keep writing the programs, you understand. Similarly, as you keep writing metrics, you will understand about it. Okay. Once different metrics types are defined, then it's about the logic in the application. Like when you want to track a particular metric, and this code is very specific, right? This is very specific to Node.js. If you have some knowledge of Node.js, you can understand when and how the metric is being incremented. Okay. So, like I said, we have different APIs also on this application. Once we deploy, we use these APIs to trigger some actions on the application. So for that, we first need Prometheus. So I have created this Kubernetes cluster. So the cluster is already there. Now I will install Prometheus stack on this cluster. So let's run this command, the Helm chat. So in the monitoring namespace, okay, it says the chat is still in use. So let's remove the Helm chat. Okay, so I have uninstalled the release. Let me try again. So the installation of Helm stack. So we are using the Prometheus stack here because we can get Prometheus, we can get Grafana, we can get Alert Manager. Abhishek, where can I get this command from? If you have followed the series, you already know it. Otherwise, go to the day2 folder, and within the day2 folder, you can find the complete steps. How to download Helm, how to create this stack, how to use them. Everything is provided, even how to expose the Prometheus UI as well. So let's copy the Prometheus UI command, the port forwarding. Once this is done, the Prometheus stack is installed. We will expose the Prometheus server. And what we will do is first, we will try to see the custom metrics by deploying the application, right? So the application that I showed you, the Node.js application, we will deploy it on the cluster, and we will see if the logic that we have written here, the custom metrics related to the HTTP request duration or related to the counter metrics that we have created, total HTTP requests, can we see that on Prometheus or not? For service A. So the name of the service is service A, right? So can I see that for service A or not? We will start from that point. And then we will see the graphs, how they are of counter type, how they are of histogram type, all that. Finally, we will cover the alert manager configuration. So now let's expose the Prometheus using the kubectl port forward command. Cool. Let's verify if Prometheus is exposed. Okay, great. So we have Prometheus exposed. All the steps are in day2 of the GitHub repository. So let's deploy our application now. So let's go back to the day4 folder, and we have something called as Kubernetes manifest repository, where the deployment of the services, the deployment file is provided, service is provided, but we would be deploying that using customize. So if you go to the README file, we have this. So the Docker builds I have already done, and if you want to use my image, you can use these images. So just go to the day4 folder and create a namespace called dev kubectl. I've created the dev namespace, and using customize, let's just apply those manifests. So the deployment is created, service is also created. Let's verify if the pods are running. Kubectl get pods and dev. So this is our Node.js application. Service A is already running. So we need to wait for both of them to run. Perfect. So service A will talk to service B. It's just a simple microservice architecture application. And if you look at kubectl get svc in the dev namespace, so service A is exposed with load balancer service type because I'm going to access this service through the user interface. Communication between service A and service B is internal. So as you know, it will take time for the load balancer service to come up. Okay, now the application is running. As I said, it's a very simple application. When you access the application, it shows the health check as running, and it also supports different APIs. So it supports slash healthy, server error, not found, logs. For example, if I just do slash logs here, so you can see a simple log that it is generating. Now our goal is to go to Prometheus, right? And try to see the custom health checks that we have instrumented in the application. Is Prometheus reading it, right? This is another important point. Can Prometheus read directly if you have instrumented the custom metrics? Let us see. So one of the metrics that we have instrumented, if you go to the application index.js, and let's see this metric that we have instrumented, HTTP request total. Let's run it. Execute. Okay, it returns nothing. Why? So this is the important point. Why Prometheus is not returning any metrics of the custom metrics that we have written? Abhishek, now the instrumentation is also done. Why is Prometheus not giving me? Because there is something called as service discovery, right? So what you have done is you have instrumented metrics, you have created the Prometheus stack, but this application on your Kubernetes cluster, there can be multiple applications, right? How does Prometheus know that from which applications does it have to fetch the custom metrics from? If it is a node exporter, it knows it has to get from the nodes. If it is a DB exporter, it knows from which database it has to get. Similarly, if Prometheus needs to know out of 100 applications on your cluster, from which application should it has to fetch from slash metrics endpoint. What is this slash metrics endpoint? Again, in the application, if you go here and type slash metrics, so see, these are the metrics our application is omitting. On the metrics endpoint, our application is providing the metrics in the format that Prometheus can understand. But Prometheus is still not reading it. Why? Because you did not tell Prometheus that, okay, so you need to identify this application. For that, there is something called as service discovery. So how service discovery is done? Very simple. You just need to deploy a custom resource or a YAML file, and that YAML file will take care of the service discovery, right? So we have that steps also provided here. So just run this command kubectl. This is the service monitor manifest. So all that I have to do is just run this command. I'll also show you the configuration. Don't worry. So we have this alert manager service monitor manifest repository. Sorry, the folder, this one. And here you have alert manager configuration.
and service monitor configuration. I will come back to alert manager configuration in just 5 minutes. But right now, let's look at the service monitor configuration. So it says in the dev namespace, okay, match the service called as service A and get the metrics on it on the slash metrics endpoint. That's it. So this will be read by your Prometheus and it will fetch the metrics that your application is providing on the slash metrics endpoint. All these metrics. So let's try to do that. Go here, run the command. Of course, alert manager will fail at this point of time because I haven't configured it completely. But our purpose is the service monitor. We will get back to alert manager. Cool. Now I have created service monitor. Let us see the same command that we have fired. Okay. I will execute again. Let's refresh. So it just took, I think, less than 2 minutes for the service monitor to reflect the configuration. No additional changes are done. I just changed this to 1 minute, the time, and I can see the graph. Like if you increase this, maybe 30 minutes, you see the graph, uh, very less graph because the application is just deployed. So just change it to, let's say, 1 minute, and you got the information about HTTP requests total. This metric was not seen before. Right now, why you are seeing it? One is you have instrumented. Second, you have created service monitor. So this is the process that you even need to probably explain in the interview or set up in your organization. Step one is instrument the metrics. If you are dealing with applications, custom metrics, step one is instrument. Step two is set up Prometheus or your complete monitoring. And step three is service discovery. So you need to tell Prometheus that, okay, these are the services that you need to identify. Using these things, the complete metrics are set up. Now, Abhishek, can I fire some alerts? Okay, you have covered the monitoring part. Now, we have also set up the alert manager using Prometheus stack. So how should I fire some alerts? So for that, what you need to do is to fire the alerts. Just you need to create a alert manager configuration file, just like how we have created the service monitor, right? So in the alert manager configuration file, you have to provide which alerts do you want to configure. For example, here in the alert manager configuration, I am saying that I need the alerts for high CPU usage and pod restarts, that is container crashes. So we will crash our container intentionally and we will see if the alerts are fired or not. And who is the receiver? Where do we want to send the alerts? So we will use our email, right? We will see if the alerts are fired to our email or not. So I will provide the receiver information as send mail, where just provide your email ID in the places that is provided. You will also need a password because if somebody has to send you an email, SMTP server, it will expect the password. For that, first you need to configure the password. For Gmail, steps are very simple. Just go to your Google account, right? Manage, go to your Gmail and click on manage Google account. You will reach to this page. Just search for app passwords. Okay. So just provide again your uh, username and password. So it will ask for app passwords. If you don't have two-factor authentication, you might not see this. So enable two-factor authentication on your email. In the app password, let's provide the name as alert manager, create, and this is the password that we got. Now we will take that username, we will take this password, and we will go back to our alert manager configuration. So in the day 4 folder, right, go to this particular thing, perfect, and go to the email secrets.yaml.
Everything is provided, and what you need to do is take this password, right? Take this one, convert this to base 64, echo. Let's put this in the double quote, base 64, and this is the one that we got. Now go back to the email secrets file, copy this, remove, and paste. Great. So this is done. Then what is the next step that is left to be done? If you go to the README file, you can see the steps very clearly. First, review the alert manager configuration, right? We have seen that. Then it says go to the email secrets. And last thing, go to the alert manager configuration file and update your email address. So alert manager configuration, and in places where you need to provide the email address, just provide the email ID, which I have done. So this is a dummy email account. No problem if I get the alerts there. So I have created one dummy email account and I have provided that. Save the file. Perfect. Now again, run the customize, because we have updated our configuration files. So I will do kubectl apply minus k dot. Okay. So the secret got configured. Perfect. Now, what I am going to do is I will verify if the alert manager is configured correctly or not. For that, what I'm going to do is I will go to my application and use the endpoint called crash. So this will crash my application. The program is written in such a way that when you do /crash, the application will be crashed. You can also see that if you do kubectl get pods -n dev. See, the pod has crashed one. And if you see after another 20 seconds, you will see the pod will crash again. Or we can just do one more time, crash /crash. Yeah. So it is taking time. Just make sure. Perfect. It is crashed twice. Now, as soon as it is crashed, you can see here on my mobile, I have got the notification. Let me show you. Immediately, alert manager has notified me that, hey, your application has crashed. See, the pod restart notification is sent to my mobile because I have my Gmail configured on my mobile. So this is how alert manager can send you the alerts, where you can configure on the pod crash, on XYZ things, whatever you would like to configure, right? So make sure you follow the notes properly, because the steps are provided each and every step. You can learn the instrumentation as well as firing custom alerts. Thank you so much for watching today's video. I hope you will find it useful. Take care, everyone. See you all in the next video. Bye bye. Hello, everyone. My name is Abhishek, and welcome back to my channel. Today is episode 5 of Observability Zero to Hero series. Till now, we have completed 4 episodes in this series, where using these 4 episodes, we have mastered the first pillar of observability, that is metrics. So we started with understanding the fundamentals of observability. Then we learned about metrics, monitoring, custom metrics, Prometheus, Prometheus query language. We learned about alerting, dashboards, everything practically in the first 4 episodes of this series. Now it's time to move towards the second pillar of observability, that is logging. So in this video, we will learn
what is logging, why is it important in the world of distributed systems. Then we will understand about a popular logging stack, that is EFK stack. What are the different components? What is the architecture of EFK stack? How different components communicate with each other? And finally, we will also learn how to install, set up, and configure EFK stack on a Kubernetes cluster using Helm chat. So this video is going to be very interesting and informative as well. Make sure you watch it till the end. And after watching the video, if you are looking for the notes for this episode, you don't have to go anywhere. Just go to this GitHub repository. Link is in the description. Observability zero to hero. You can see already 2000 plus people have forked this repo. 1400 people have started the repository. It's very useful. Go to the day 5 folder, and if you click on the readme file, you can get the complete notes that I have explained in the series. In this episode, you can see the architecture diagram, the commands that I'm going to use, and also the manifests that are used in the video. So you can use this particular repository for your revision purpose. Okay, now let's move to the whiteboard and start with understanding what exactly is logging and why is it very important. If I have to explain this in simple layman terminology, logs are nothing but messages that are written by the developers in the application or in the program to help end users understand what is the application doing at a particular point of time, so that you can debug the application, and if the application is not working as expected, it can tell you why is the application not working as expected. Let's take a simple example. Assume there is a developer, and this developer is asked to write a simple program, addition of two numbers. Now, if this developer just write the application without any log messages, for example, defines a variable and expects a command line argument, defines another variable, expects the second command line argument, then just says C is A plus B, and finally print C. Obviously, this is also a program that would work, but when it is given to a user who does not have any idea about this application, so user would execute this application, and what the user would see is a prompt that is expecting an input from the user. But the user would not understand if the prompt that is waiting for the user, is it expecting a string? Is it expecting an integer? Is it expecting a Boolean value? What exactly is it? And what is the program doing? So ideally, what developer should do is, instead of writing this way, developer should write a log message at the beginning of this program explaining, as soon as you execute, the program waits for two command line arguments or two numbers as input. Then obviously the program would be same. A is equals to first command line argument, B is equals to second command line argument. Now that the user has understood, user provides two numbers, the command line arguments are read, and C is equals to A plus B, finally print C, right? So with the log messages, the end users understand what exactly is the application doing, and if the application is not working, or there is some issue with the application, these log messages will help the end users debug the application, further understand what is the issue and why is the issue causing. A simple shell script without logging and with logging can clearly explain you, like here, the shell script of addition of two numbers without any log messages would look something like this. Whereas with proper log messages, the shell script explains the person executing the program that, hey, starting with the addition process is complete and this is your output. So logs are important. This is a very simple application. Assume if the application has 10,000 lines of code and suddenly the application has stopped working. There is some issue with the application. How would you know at which point the application has failed? Did it fail at the 5,000 line? Did it break at the 6,000 line? And why did the application break? Is it issue with the index out of the bond? Is it issue with the exception that you did not handle? What is the issue? Why is the issue getting caused? So this is where logs come handy. You look at any applications today, the open source applications or applications that are written in your organization, you would find a lot of log messages. At every point or in every critical step of the application, you would see a log message so that if that critical step is failing, this log message helps the end user understand that, hey, your critical step has failed and this could be the reason why the critical step has failed. Even if you have followed the first episode of this series where I was explaining about observability, I explained that there are three pillars of observability. First one is metrics, second one is logs, and third one is traces, where metrics explains what is the state of the system, and if something goes wrong with the system or application, logs will help you understand why why the applications are failing, what is the reason why the application is failing, and finally traces, which we are going to cover in the future classes, will help you understand how to fix the issue, right? So logs focus on why a particular issue is caused and how can you debug further, how can you troubleshoot further. Now the question is, but Abhishek, you were talking about EFK stack. So what exactly is it? Why do I need this thing? So if you take scenario where you have hundreds of applications or hundreds of microservices in your organization, and each of them are running in different places. If you take a Kubernetes cluster, you might have 10 applications in namespace 1, 10 applications in namespace 2, 10 applications in namespace 3. And imagine there is a scenario where there is a log4j issue or there is issue with the database connection among some applications. How would you know amongst the 100 services that are running in different namespaces, which of these services has a database connection issue? Maybe a temporary database connection issue. Sometimes the issue is there and sometimes the database connection is established properly. But you are asked to troubleshoot this intermittent database connection issue. That is once in a while database connection issue. Now, if you have 100 plus services, how would you know in which service this database connection issue is there and in which service the database connection issue is not there? You can go to all of the 100 applications, go to the pod logs, and you can see in each of the pod log if, okay, this particular pod, does it have any issue in the logs? Second pod, third part, you can go to 100 different pods. Otherwise, what you can do is you can create a centralized logging system where all the application logs, all the services logs are collected at one place. And at this place, you can execute a query either through the query language or through the user interface or through the CLI. But if you have a centralized logging system where all the logs are aggregated and you just search for DB connection message or connection timed out message or a particular error that you are looking for, and the query that you have executed or the error that you are looking for is searched amongst all the 100 services on this centralized logging system. It would be very beneficial, right? Because instead of going through 100 applications, each and every application in different namespace, you can go to this centralized logging system, which is the EFK system. You can go here and you can execute a query and get the required output that, okay, in service 1, service 10, service 15 and 40, there is a database connection timeout issue. And you can tell the developers that, okay, these are the 4 services that you have to work on because temporarily or intermittently I'm seeing DB issue on it. And whenever there are critical vulnerabilities, so you will have less time to react. The log4j issue or any vulnerability which are critical security issues, if you have such centralized logging systems, it would be easy to identify the vulnerable services very quickly and react immediately. Now, what are each component of EFK stack doing? Like, why do you have 3 different things? So to explain, EFK, where E is Elasticsearch and F stands for Fluentbit and K stands for Kibana. If you have followed the monitoring classes, just like how you have Prometheus, where Prometheus has a time series database where all the metrics are stored in a particular format, and Prometheus uses exporters such as the node exporter or any other exporters, the database exporter, to retrieve the metrics from the applications, right? And there is a graphical representation or proper dashboards in the Grafana. So a user would come to Grafana, look for a dashboard, execute a query. So the query is executed on the time series database of Prometheus, where these exporters are storing the metrics taken from the application in the time series database. Similarly, exactly like the metrics architecture, here you have different applications, right? Let's say you have 3 different applications which are deployed on the Kubernetes cluster. There is something called as Fluentbit. Let me just write it as FB. Fluentbit, which is deployed as a daemon set, exactly like your exporters, the node exporter or any other exporter in the world of metrics. Here you have Fluentbit, which is deployed as daemon set. What does a daemon set do? It is deployed on each node of the Kubernetes cluster, and this Fluentbit reads the logs from the pods of the Kubernetes cluster at a particular location and forwards these logs. So it forwards the logs to Elasticsearch, which itself is a database. So the logs are stored in the Elasticsearch. You can attach Elasticsearch to things like EBS volumes so that you can take a backup of logs on the timely basis. You can create snapshots. And then there is a visualization dashboard such as Grafana, which is Kibana. So if you have followed the metrics, it would be very, very simple to understand this architecture. That's why I told you at the beginning of the video, if you have followed metrics, logging is very, very simple because kind of the architecture is the same. Now you might feel there is Elasticsearch, there is Fluentbit, there is Kibana. Why there are so many components? It is very confusing. But if you understand this flow, what is Fluentbit doing, what is Elasticsearch doing, and what is Kibana doing, it is very, very simple. Let me repeat this one more time because this is the core part. This is the very important part of logging. So even if people ask you in interview, what you can explain is in the EFK stack or in the FEK stack, because it is also called as spec stack. The first component that you have is Fluentbit, where Fluentbit reads the log messages from the nodes of the Kubernetes cluster. It is a daemon set deployed on every node of the Kubernetes cluster. We are going to see this configuration practically as well. Don't worry. So from every node, different Fluentbit instances takes the log messages and forwards these log messages to Elasticsearch, which itself has a database, and Elasticsearch keeps all the log messages. Now, logs are quite heavy, right? Because your application omits thousands of logs. And if you have hundreds of such applications, so the database will become very huge. So it can go up to GBs every day. In classic banking applications or in classic financial applications where you have multiple services, each day your Elasticsearch, the database, can even get some GBs of logs, maybe 1 GB, 2 GB, 3 GB of logs. So it is better to create Elasticsearch as a persistent volume and connect it to maybe the EBS volumes, and every day you can take snapshot of these EBS volumes. And because it's a database, sometimes it is difficult to query. uh, of course you have the query language, you can query the Elasticsearch directly, but to make it easy for the end users and for better visualization experience, just like what Grafana does for you, you have something called as Kibana. So end users can use the Kibana UI, can execute or fire some queries, which are basically getting out some values from the Elasticsearch and giving that back to the user on the Kibana dashboard. Fluentbit is doing the underlying job of collecting the logs. It can collect different kinds of logs from different input sources and forward that to the Elasticsearch. So the architecture is clear now, right? I know many of you at this point have a question that, Abhishek, why EFK stack and why not ELK stack? You could have explained ELK stack in the series. Why did you go for EFK stack? Unfortunately, a lot of people don't realize that EFK stack is more than enough for them. So in this case, ELK stack is Elasticsearch, Logstash, and Kibana. So if you observe, Elasticsearch is common, Kibana is common. Only difference is that Fluentbit versus Logstash. In again simple words in layman terminology, Logstash has more rich features when compared to Fluentbit. Fluentbit is just a log forwarder, whereas Logstash is log aggregator. So, along with collecting the logs, just like how Fluentbit collects logs from every node, but Fluentbit will directly forward the logs to the Elasticsearch. Whereas with Logstack, you can filter out the logs. Of course, you can do that with Fluentbit as well, but only to some extent. With Logstash, you can do advanced filtering, you can do advanced labeling, you can perform some more actions at the Logstash before they are forwarded to the Elasticsearch. But many organizations don't need it. So if the if Fluentbit is forwarding the logs to Elasticsearch and proper backup of Elasticsearch is taken, Fluentbit is more than enough. And this is very lightweight when compared to Logstash. And the chance of issues with Fluentbit is also very, very less when compared to Logstash. In future classes, when we do projects on ELK stack or projects on observability, I would cover Logstash as well. But right now, if you are starting, start with Fluentbit because it is very simple, very lightweight, and it does its job by just forwarding the logs to the Elasticsearch. Okay, now can we proceed with deploying the EFK stack? Yes, let's do that. So let's take our Kubernetes cluster. So this is my Kubernetes cluster. I have the cluster created already. You can use the same cluster that you have created in your previous classes as well. If you are following the series and if you already have a cluster, that's perfect. You can use that. All that I need is a Kubernetes cluster that is set up with the nodes. And if you go to the README file, you will find the first thing that you have to create is create a IAM role for service account. Why is this needed? Because as I've explained, first you will have the Fluentbit, which is forwarding the logs to Elasticsearch. But we will use Elasticsearch as a stateful set and we will mount it with EBS. Now I'm using EKS cluster. This is a very important concept. People fail to understand this and mostly these are asked in the interviews. Like my Elasticsearch is on the Kubernetes cluster, whereas EBS is outside the EKS cluster. Of course, both of them, both the Elasticsearch and the EBS volumes are in the AWS environment, but one is in the EKS and other is EBS. So the volumes are EBS volumes and Elasticsearch is in EKS. Now, how can the EKS cluster, the Elasticsearch in the EKS cluster, communicate with the EBS volume? So what you would do here is you would map the service account of the Elasticsearch with a IAM role, right? So we will use an IAM role where the Kubernetes service account of Elasticsearch is mapped to the IAM role, where this IAM role can create a EBS volume or can talk to the EBS volume. So this cannot be done directly. For this, the another step that we are going to do is we are going to use a CSI driver for EBS. This CSI driver will create the EBS volume and the storage class and persistent volume claim are created accordingly. So let's start with creating the service account. I will go back to my cluster and here The name of the cluster that I'm using is observability 1. In your case, you don't have to change it. I have another cluster where I'm doing the tracing part. So that's why I'm just for the separation using the cluster name as observability 1. Okay. So the IAM service account is getting created. So this will be the service account that we will use in the uh, Elasticsearch. And next one is to, once the command execution is complete, we will retrieve the IAM role name. Okay. So the IAM service account is created. Now let's retrieve the role name. Okay. We got the role name. I stored it in the ARN, the variable called ARN. Now it is time to deploy the CSI driver. I told you why CSI driver is required. It is required because in the EKS, when you use the persistent volume claim and if the storage type is EBS volume, you need a driver that can create the EBS volume for you. So this is where CSI driver comes into picture. So again, I have to change the cluster name to observability 1. You don't have to change it. So, okay, the add-on is getting created. The CSI driver is done. Now let's create a namespace called logging. Why is this required? We are going to deploy our EFK or fetch stack onto this namespace. Cool. Let's deploy component by component. Let's start with Elasticsearch. First, I need to add the Elasticsearch repo. Okay, it says it's already there. Good. Then let's run Helm install Elasticsearch. And here the volume claim type. In the Helm chart, I am passing an argument where the volume claim type is of storage class GP2, which is for EBS. Perfect. Now the Elasticsearch would be installed. We need to retrieve the username and password for Elasticsearch because when your log forwarder, that is the Fluentbit, when it wants to forward the logs to Elasticsearch, as I've explained here. So if the Fluentbit has to forward the logs to Elasticsearch, it would need authentication, right? Because it is pushing the logs. So you need to take the username and password of Elasticsearch, which we are just creating. And when we deploy the Fluentbit, we will pass that username and password in the Fluentbit configuration so that Fluentbit can talk to the Elasticsearch. Cool. Elasticsearch is created. So let's get the username. I think the username is Elastic. Perfect. And let's also get the password. As soon as you get it, keep them handy because when we are going to install Fluentbit, we are going to pass that. And let's install Kibana as well. It's easy. So for Kibana, I'm doing the service type as load balancer type because I want to use and access Kibana from the user interface. And once Kibana is also installed, what we will do is proceed with the Fluentbit. So the repo is already added in my case. I'll not do it. But this is the command for installation. Before that, we have a values.yaml file in the day5 folder. You need to update the values.yaml, right? So don't confuse looking at the length of the Fluentbit configuration file, the Helm values.yaml. You will not change most of the things here. You would only change couple of things, which I'm going to explain. Okay, this is also done, Kibana installation. Now, if you go back, so this is the command for installation of Fluentbit. But before executing that, let me clear the screen. So before executing it, you need to update the values.yaml. So what we will do is, sorry, I forgot to save the Elasticsearch credentials. So this is the password. Now I will copy the password and vim fluentbit.yaml file. Just search for http, not this. So you have http user and http password. So go to the http password and just change the password. Similarly, in the next section as well, there are two output sections. Uh, in the Fluentbit, what is output section? I will cover in a while. Basically, it is outputting the logs or forwarding the logs to Elasticsearch master, which is the stateful set. So just make sure the password is provided here as well. Cool. So save this file and just run the Helm install command. Before that, you need to add the Helm repo as well, but in my case, I already have it. Okay, it says there is some issue at the line number 449, probably the indentation issue that might have created. 449. Yep. So there is an indentation issue here. Let me just remove these. That is not required. Perfect. So Fluentbit installation will also be done. And once this is done, cool. So this is also done. What we will do is, let me take another tab. Just check kubectl get pods in the logging namespace. Do I have Elasticsearch running? Yes. It's a 2-node Kubernetes cluster. That's why we have 2 pods of Fluentbit, right? That is the concept of daemon set. N number of nodes that you have, you will see n number of replicas of the pod, each replica running on one node, because it has to fetch details from the node. So we are running Fluentbit as daemon set. Kibana is also running. And when you do kubectl get svc logging, you can see Kibana, I have created the load balancer service type. So just copy it. Take browser, use port 5601. Everything is explained in the notes as well, so you don't have to worry. And here the username would be Elastic and password would be the same, the one that we have retrieved. Let me retrieve that again. The base 64 encoded. Yep. So now you have the Kibana dashboard. Okay. So this Kibana dashboard is automatically connected to Elastic and your log stash is forwarding the logs. So right now you will not see any logs here and there would not be any integration because we don't have any applications on our Kubernetes cluster, right? If you go here and click on the discover, you will see that, okay, you have data in Elasticsearch, created data because the data is coming from other namespaces, other pods, but I don't have application created for myself. So what we can do is we can deploy some application to test if the logs of that application are seen in the Elasticsearch. Is Fluentbit forwarding the logs to Elasticsearch and can we see that on Kibana or not? What we can simply do is go to the day 4 folder where I have an application. So just go to service A, and or let's go to the README file where I have provided the steps of installation of this application. So we will just create a namespace called dev, switch to day 4, or you can install any other application, pick up an open source application and you can also install it. That's up to you. So let's create a namespace called dev, and within this namespace, let me just apply the manifest. Okay, service A is created, service B is created. Now I just have to wait for kubectl get pods in the dev namespace. They are still creating. Cool. So the pods are created, and if I just log a particular pod, kubectl logs, let me just get the logs of it in the dev namespace. So there is a simple log. I just said service A is running on port 3001. Cool. So now the logs are there. If you use kubectl get pods in the logging namespace, and I want to see if Fluentbit, any replica of the Fluentbit, was able to understand that service A is created and is it able to pull the logs of service A or not. So kubectl logs, let's look at this Fluentbit instance. And if I do the logs, okay, so initially you might see this warning message where it is saying fail to flush, but you can see here that it has identified the service B. So service B deployment. And if you scroll up, you can also see a message for service A. So ignore this warning message. Whatever it is saying, fail to flush the chunk. It is not an error message. It's a warning message. You can also get rid of it, but for now that's okay. All that I want to show you is there is an info message in the Fluentbit saying that it could find service B deployment and service A deployment. And it has forwarded that to the Elasticsearch. So now in Kibana, create a view. Let's call it as log management. And you can also provide a log pattern. For now, let me just say it as so you have two log patterns already here. So you can select one log pattern and save data view for Kibana. As soon as you do it, see, you can see the logs that are already recorded. So you have logs coming from different namespaces. You have logs coming from your application that is created for you. And you can also see the timestamps, right? So how is Kibana getting this? From Elasticsearch. How is Elasticsearch getting it? From Fluentbit. You also have, just like Prometheus query language, you also have something called as Kibana query language, using which you can filter out a particular log message. Like some of them are coming from kube-proxy, right? So if you want to get rid of kube-proxy namespace and you only want to see the namespace called dev, you can do that from the Kibana query language. So I mean, right now I'm not focusing on the Kibana query language because it itself will take a complete class. The focus is to explain you the setup of the fetch stack and explain how the log forwarding is done and how the components talk to each other. And one thing that you should focus is on the Fluentbit configuration. Another advantage of Fluentbit is that it is vendor neutral. Tomorrow, if you want to move from, let's say, Elasticsearch to Splunk or to any other log management platforms, Fluentbit can work as is. Whereas if you are using Logstash, you can restrict to a particular platform, and that would become a bottleneck for you. So in Fluentbit, make sure you go through this Fluentbit configuration file. So there are four primary things in Fluentbit configuration: the service, input, output, and filters. So service is basically for the service configuration, like you want to expose uh, the Fluentbit in node port mode, cluster IP mode, or you want to add enable any particular feature of Fluentbit. Then you have input. Where is the input coming from? In our case, the input is coming from the container logs. So if I just search input here, so you can see the input is coming from var log all the containers. So start.log. So typically all the container logs are taken as input. That is where we are reading from the pod logs. And you have the filter section where you can filter out, let's say in this case, if you go to the Kibana, you will not find any logs from the logging namespace. Where I have installed Elasticsearch, Kibana, and Fluentbit, I have omitted or ignored that particular namespace. You can see that in the Fluentbit configuration. If you go to the configuration file and if you look at the filters, you can see I have used a Lua script file. Of course, this will take time for you. It would need some experience as you keep using Fluentbit. This is the very first class. So you might find the Lua script overwhelming, but in the Lua script, you can do the filter outs where you can say, ignore a particular namespace. In this case, I have ignored the logging namespace. Similarly, you can ignore the kube system namespace or the any Kubernetes API related components. And finally, you have the output section where we have updated the password. So in the output section, you will define where the Fluentbit has to forward the logs. In our case, we said it is Elasticsearch. The host name or the service name is Elasticsearch. Port is 9200. And this is the username and the password. If you are running this on AWS cluster, EKS AWS cluster, make sure the TLS is on. Otherwise, the connection will not establish. Perfect. So this is the output section and this is the output configuration. So you can go through the Fluentbit documentation. It would take probably 1-2 days to master the Fluentbit configuration. And if we get time, maybe after this observability series, I would make a detailed video, as I told you, on Logstash, similarly on the Fluentbit as well. Perfect. So make sure you practice this and make sure you have your Kibana setup with different applications and you see the logs for it.
Hello everyone, my name is Abhishek and welcome back to my channel. Today we are at day 6 of Observability Zero to Hero series. Till now, we have completed 5 episodes in this series where we learned about 2 pillars of observability, metrics as well as logs. In today's video, we will learn about distributed tracing, which is the third pillar of observability using Jaeger. In this video, we will learn what exactly is Jaeger, what is its architecture. Then we will also learn more about tracing. How would it help developers, DevOps engineers, SRE engineers? Then we will see how to install and set up Jaeger on a Kubernetes cluster using Helm. We will also see how developers
instrument tracing. I'm going to share you the complete code using Open Telemetry, how developers can instrument the tracing in their applications. And finally, we will also look at the demo. So by deploying a demo application, we will see how to view and analyze traces on the Jaeger UI. And we will also cover the cleanup and complete uninstallation of Jaeger as well as the cluster. So this video is going to be theoretical as well as practical. And I'm sure after watching this video, you will get a clear understanding of distributed tracing. So make sure you watch this video till the end. And after watching this video, I would highly recommend you to go through this GitHub repository. And if you go to the Day6 folder, you will get the complete notes. And the reason why I'm asking you to go through the notes is because we have taken utmost care in preparing these notes along with the architecture diagram, commands that we have used, I mean, that we will be using in the video, and the manifest files as well. Everything is shared in the repository. We have taken a lot of time to prepare these notes. So make sure you use it as your revision purpose. Okay, now let's move to the whiteboard and let's understand tracing. In the previous classes, we learned that there are three pillars of observability: metrics, logs, and traces. We already learned about metrics and logs. Now let's understand what is traces or tracing. I will start with a real world example. Let's say you are in Hyderabad, India, and you have a friend who frequently travels between Hyderabad and Boston in the United States. And this time, your friend invited you to their house in Boston. And you have never traveled to Boston before. So, the very first thing that you do is you prepare a travel itinerary, that is, how to reach from Hyderabad to Boston. And you research on the internet, you identify that, okay, first you need to go from your house, you need to take a cab and reach the Hyderabad International Airport. And from there, you take a flight to Dubai or Abu Dhabi or maybe London. And from there, you take another flight to Boston in United States. And from the Boston airport, you take a cab to reach to your friend's house in Boston. So this is your travel itinerary. And because this is your first time, you started noting the time that is taken between each point. That is, from Hyderabad airport, it took you 45 minutes to reach the Hyderabad airport. And to reach Dubai, it took, let's say, 3.5 hours. And this long flight, assume it took 12 hours for you. And the cab took 2.5 hours. And the overall journey, let's say it took some 25 hours for you. And you shared this entire thing with your friend after you reached the house. And your friend said, oh, it took 2 hours more for you. That is, generally when I travel, it only used to take 23 hours. But in your case, it took 25 hours. Now your friend decided to trace, identify what went wrong. So you shared your travel itinerary, you shared the time between the points, and your friend noticed that the cab that you have taken from the Boston airport to his house in Boston should only take 30 minutes, but it took 2.5 hours for you. And that's where your friend realized that, okay, you have taken a wrong cab, because of which there was 2 hours delay in your complete journey. So how are you able to trace the issue? because of the travel itinerary and the timings that you have noted. Now you can relate the same thing into the world of where software engineering, where in the world of microservices, let's say you are working for a e-commerce application or you are developing a e-commerce application, and there is the login service which has to talk to the payment service. So in the world of microservices, that is, as a user, when you want to talk to the payment service, your request went to the login service where you are authenticated and authorized. From there, your request went to, let's say, a service called service A. And from there, it went to service called service B. And from there, it went to the payment service. So you finally reach to the payment service, but your request went through multiple hops or multiple microservices. In the world of microservices, it is common that your request might travel through multiple services. There can be multiple hops. It can be network appliances. It can be load balancers. It can be the proxies. There can be multiple things in between. Now, how would you identify? Let's say this request has to take 1 second, but somehow this request of user to reach the payment service through the login service is taking 4 seconds. Now, how do you identify what is creating this latency or what is creating this delay of 3 seconds, which is very, very costly if you are dealing with e-commerce applications or banking applications, anything. So for that, you need tracing. Just like how the travel itinerary along with the timestamps helped you in the world of software engineering, in the world of microservices, you need something called tracing, which is exactly similar to this. So your tracing should provide what are the different services or what are the different hops that were involved in the communication, because to the end user only knows that he or she wants to communicate to the payment service. But if the tracing is available, the end users or the DevOps engineers or the SRE engineers or the developers can understand the request first went to the login, then it went to the service A, then it went to service B, and finally it went to payments. Where from service B to the payments, the ideal time was, let's say, 30 microseconds, but it took 60 microseconds. So now you will start debugging, you will start troubleshooting, or you will tell your developer that, okay, so using tracing, I have identified, that is, as a DevOps engineer, you will tell your development team or you will create a issue with them that the 30 microseconds, which is the expected time, is not meeting the expectations. Now it is taking 60 microseconds. Please go ahead and investigate what is the problem. So all this is possible only if you have implemented tracing in your applications. Now, how do you implement tracing? This is important thing, right? Okay, Abhishek, I understood what is tracing. So tracing is basically identifying or understanding the route, understanding time taken between each hops of my request. Okay, I got it. But how to implement tracing? Like if I give you a application from GitHub, does it come with tracing? No. So to implement tracing, there are two parts. So the first part is the developer of the application or the developers of the application. They have to do the instrumentation. That is in their application. Don't worry, I'm also going to show you how instrumentation will take place. I'm going to give you the complete code of the application so that you can also try it at your end. So developers have to do the instrumentation, just like within the application, how developers instrument the metrics, how developers instrument the logs. Similarly, developers should also instrument the traces. Now it depends. There are multiple programming languages. Each programming language has some modules, plugins, libraries, but a preferred standard is to use Open Telemetry. So Open Telemetry is gaining significance and it is vendor neutral as well. Tomorrow, if you want to move from one tracing tool to the other tracing tool, it would be easy. So people these days use Open Telemetry as standard. But a point to note, there are multiple other libraries, there are multiple other modules which can help you write tracing in your application. So what developers do is they instrument tracing. For example, if you go to the day 4 folder where we have a test application or demo application, you can see in the application folder, if you go to service A, there is a file called tracing.js. And here, using the Open Telemetry libraries within this application, we have instrumented the tracing. And similarly, in service B as well, you can see there is a file called tracing.js, and using which we have instrumented the tracing in this application. Now, tracing can be even more deep. That is, not only from service to service, you can also define instrumentation, or you can define tracing at the function level. So you can understand from which function of a service the application routed to another function, from there it went to another service. So it's up to you how much level of tracing you want to implement. So this part belongs to the developers. Then there is other part, that is DevOps engineers and SRE engineers. The responsibility of the DevOps engineers and SRE engineers is to implement the tracing. Implement in the sense, so they need to deploy the tracing related tools. For example, in this video, we are using Jaeger, which is a open source distributed tracing tool. So, but there are multiple other things, not only Jaeger. You can use Datadog, you can use Dynatrace. There are multiple applications these days in the market, but a popular one is Jaeger, which is very lightweight, very simple. If you have a startup, I would recommend to start with Jaeger. Even if you are working in an MNC and you have to implement the tracing, start with Jaeger. It is very simple. UI is also very minimalistic. It will not confuse you. So the DevOps engineers, they set up the Kubernetes clusters, they set up the required configuration and install and configure Jaeger. So only if both of these things are done, you can implement distributed tracing. If one of these things is not there, let's say you have, as a DevOps engineer, site reliability engineer, you have created a Kubernetes cluster, you have installed Jaeger using Helm chart, and you have created other configuration, which I'm going to cover in next 5-10 minutes. And the developers of your organization did not instrument the traces. There is no point. Of course, you can get some very minimal tracing, because these days the tools are also very capable. They can get through some sensors, eBPF sensors, but that information is minimalistic. You cannot compare that with the tracing that comes with the instrumentation by the developers. Okay, so this part is clear. Now, how does Jaeger actually work? Now, this is very interesting. So if you have followed the previous classes, where let's take example of Prometheus. The interesting part is that whether it is Prometheus or it's Elasticsearch or the EFK stack that we have learned, or Jaeger, all of them kind of have similar architecture. So if you know one of these architecture, it becomes very simple for you to understand. Let's say you know the Prometheus architecture, it is easy for you to understand EFK and Jaeger. Let's see why. So when we were learning about Prometheus, I told you that in Prometheus, you have exporters, and what these exporters do. So they are deployed as the daemon sets, and they extract the information from the Kubernetes nodes. If you take node exporter as an example, so the exporter is the one that is basically getting the information from nodes of your Kubernetes cluster. It can be the CPU utilization, memory, disk utilization. Exporter is getting it. And exporter keeps this information at a particular API endpoint. Who scrapes this information? Prometheus scrapes this information. And what Prometheus does? It saves this information in a time series database. And then using the Prometheus UI or using the PromQL, you fire a PromQL query to the Prometheus, to the HTTP server of Prometheus, and it gets this information from the time series database, retrieves it, and gives it back to the user or displays that on the user interface. Exact same architecture in terms of EFK stack as well. You have, whether you have logstash or you have the Fluentbit. Let's take Fluentbit. So what Fluentbit does is it works as an exporter similar to the Prometheus node exporter. So it gets the information from your applications. It keeps the information with it and it forwards the information. In the world of Prometheus, Prometheus is scraping it. Basically, it's a pull mechanism. In EFK stack, you have the same architecture, but here the Fluentbit is forwarding. So it is a push mechanism. Where does it forward? It forwards that to Elasticsearch. And in Elasticsearch, you have something called ElasticDB or the Elasticsearch DB. And whenever a user wants to get the information, so using the Kibana or using the user interface, again, they fire the Kibana query and the query is again executed against the database and database gives this information back to the user. Same with Jaeger as well. In Jaeger, you have 4 components. So the first component is basically the agent, where agent is the one that gets the traces from the application. And point to be noted, agent can only get the traces if the developers have instrumented the tracing in their application. And then you have something called as collector. Now, what does the collector do? Collector collects this information, right? Agent gets the information and collector keeps the information with it. And then you have a database. So Jaeger or Jaeger, it is not opinionated. You can use your own database. For example, you can use Elasticsearch. So by default, it does not come with a database. You need to configure. I'm going to show you how. So the collected information can be stored in the Elasticsearch database, or you can use Cassandra DB. Multiple things are supported. Elasticsearch is a preferred option. It is also very fast. And finally, you have the user interface, where with the user interface, you fire a query to the collector. It gets the information through the Elasticsearch DB and displays it to the user. Now, the same thing is also mentioned in the notes. If you go to the day 6 and if you go to the day README file, you can see there is an agent that collects the traces from your application. Then there is collector, receive traces from the agent and processes them. Then you can fire a query through the UI, and storage, as I explained, you can use databases like Elasticsearch or Cassandra DB, multiple things. So the architecture is pretty simple. And now that we have learned about metrics, we have learned about logs, and we have learned about traces, you can go ahead and look at this complete architecture of observability. I'm sure if you have followed all the classes, you will understand this. So, I have clearly mentioned in this architecture diagram about the complete observability. You have Prometheus for metrics, you have Alert Manager for alerting, and the architecture is very simple. You have node exporter that is running, Fluentbit that is running, and Jaeger agent. So as I explained here, Prometheus exporters are running on the cluster, Fluentbit is running on the cluster, and Jaeger, the agent of the Jaeger, is also running on the cluster. So overall, when you implement observability using the stack that we have used, you have three different utilities or applications that are running, which is taking the responsibility of collecting the information. One is your exporters of Prometheus, which is collecting the metrics information, running as pods on your cluster. Then you have the Fluentbit, which is collecting the logs. And finally, you have the Jaeger agent, which is collecting the traces from the applications. And they are deployed on Kubernetes. What they do, the node exporter forwards that information to Prometheus, or Prometheus is scraping that information. Then the Fluentbit is forwarding that information to the Elasticsearch. And here, Jaeger is also available in this architecture diagram. The reason why I did not represent Jaeger separately, because Jaeger stores that data in the Elasticsearch itself. So that's why I did not have Jaeger anywhere here. And from there, users get three interfaces: Grafana for metrics interface, Jaeger query, that is the Jaeger user interface for distributed tracing, and Kibana for the log interface. So at the end of the day, if you are the DevOps engineer or SRE engineer, you are going to share these three URLs with your team. So Grafana URL, share with them. Jaeger URL, share with them. And Kibana URL, also share with them. If you want to implement RBAC, if you want to implement SSO, that's a different thing. But this is what you do. You might be thinking, Abhishek, why there is a EBS volume here? Because when it comes to logs as well as traces, because you are storing that information in a database like Elasticsearch or Cassandra, it is important that you take snapshots of this. So to the Elasticsearch, we use the CSI driver for EBS, and this CSI driver, using the persistent volume claim, it creates a persistent volume, and that persistent volume is attached to the Elasticsearch. You will see all that during the demo as well. Okay, so the architecture is also clear. So now let's go ahead and try to deploy this thing. We will deploy the Jaeger, we will deploy Elasticsearch, and we will deploy sample application to see traces on the Jaeger user interface. Let's start with the Kubernetes cluster. So to save time, I already have the Kubernetes cluster, but without any configuration. If I do kubectl get nodes, so you can see that I have a EKS cluster here. If you want to know the steps, Abhishek, I also want to create the EKS cluster. Don't worry, just go to the day2 folder and go to the README file. You can find the complete steps how to create EKS cluster. Let me increase the font size. So how to create an EKS cluster, how to attach the node groups to it, everything is available in this README file. Okay, now that's the Kubernetes cluster is available. What is our next step? Go to the day 6 README file and start with the steps here. The first thing that you have to do is you need to have Elasticsearch, because when you try to install Jaeger, at the time of installation of Jaeger itself, you will provide the Elasticsearch password, Elasticsearch URL, so that Jaeger talks to Elasticsearch and stores the information in it. So Elasticsearch is available in the day 5 README file. Go there. First, we create a service account. This service account is required to interact with the EBS volume. So where is my terminal? Perfect. So here is my terminal. So what are we doing here? EKSCTL create a service account. Why are we creating this service account? Because the EKS cluster or Elasticsearch is in the EKS cluster and EBS volume is a complete different one. It is outside the Kubernetes cluster. Two different services of AWS. How do they interact with each other? You need a IAM role. How can a service in Kubernetes use the IAM role? It's not possible. So what you do is you integrate the service account with the IAM role. Let me explain this through a diagram because it is important. So you have a EKS cluster, and within the EKS cluster, let's say you have Elasticsearch. You want to use EBS as a persistent volume. How can this Elasticsearch pod within the EKS cluster use the EBS volume? You know, in AWS, if a service wants to communicate with another service, one AWS service to communicate with another AWS service, you need a IAM role. But this is for service to service communication. Your Elasticsearch is a pod inside the EKS. So what you do is, for this Elasticsearch, you create a service account and you tie this service account with the IAM role. Again, how do you do that? You will use the OIDC connector. I have explained this thing practically in the previous classes as well. But for this particular class, this information is enough. How does Elasticsearch use EBS volume? Is using the service account and tying that with the IAM role. So we have created a service account. Now let's get the ARN of that service account. Okay, service account is creating. Perfect. Let's get the ARN of it. So ARN is stored in this variable. Next step is to create EBS CSI driver. Without CSI driver, it is not possible to use the persistent volume as EBS. Okay, there is some network issue. Just give me a second. Let's try again. Cool. So now the CSI driver is also created. Next step is to create a namespace for logging. We will deploy Elasticsearch in the logging namespace. It is better to use different namespaces, even though you are implementing observability. Create a namespace for monitoring, create a namespace for logging, and create a different namespace for tracing, so that you can implement different RBAC. It is easy for troubleshooting as well. Okay, it says logging namespace already exists. Then we will use the Helm chart for Elastic. And using this command, we will set up the Elasticsearch. And after you set up Elasticsearch, keep a note of the username and password. It is very important because in the Jaeger, we are going to provide, in the Jaeger configuration, we are going to provide Elastic as username and this one here as password. Cool. So keep a note of this password, or you need to run this command one more time during the Jaeger configuration. Okay. So Elasticsearch is set up. Now let's proceed to day 6 and start with the Jaeger configuration. So along with the Elasticsearch password, we also need to extract the CA certificate for the secure communication. So we will extract the Elasticsearch CA certificate, and then let's start with the tracing namespace. So create a namespace for tracing, then create a config map where you will store the Elasticsearch CA configuration. Because to provide this information to Jaeger, what is the obvious resource in Kubernetes? Config map are secret. This is not that sensitive, so you can use a config map. Cool. Now, what you will do is you will create a secret. So this is a generic secret that you have created. And finally, you will deploy Jaeger. The Helm chart is available. Just run Helm update if required. And finally, run this command. Now, before running this is where in the Helm chart, in the values.yaml, if you go to the values.yaml here, so you need to update the username and password. There are simple, straightforward sections. One is for the collector, one is for the query, that is the user interface, one is for the storage. So this part is for the storage, this part is for query, and this part is for the collector. So we are not modifying anything related collector, and we are not modifying anything related to the user interface. Only thing that we will modify is the storage information. If not Elasticsearch, let's say you want to use Cassandra or something, you can go ahead and change that information here. But for Elasticsearch, the service name will remain the same. The port will remain the same. We are using secure communication, so HTTPS will also remain the same. Only thing that will change is the password. So let's get the password one more time. Base 64. Yeah, I think this is the password. No, this was the username. My bad. Okay. Yeah, I think this is the password. So I will copy this password here. Go to the file called jaegervalues.yaml and just update this password. Without updating the password, please do not start with the Jaeger installation. If you do that, again, you need to modify and run the Helm update. It's not a big problem. So if you have messed up with the password, once you do the Helm install, what you need to do is Helm update. Upgrade. Okay. So now Jaeger is getting installed. Perfect. Let's use the Jaeger user interface through the port forward command. So some people were complaining in the comment section that the port forward does not work for them. It's very simple. You might be using EC2 instance. I'm using my laptop. So if you are using EC2 instance, to this command, just add hyphen address 0.0.0.0, and then you can access the user interface through the IP address colon port. So instead of using this particular thing, that is 127.0.0.1, use the EC2 instance IP address, but you need to add this to the port forward command. Okay, let's try to access this. Okay, it says there is some problem loading. Let's try to see why. Oh, did we stop? Let's run the port forward one more time. And let's access this again. Okay, so the port forward seems to be failing. Let's see what is going wrong. If we do kubectl get pods in the tracing namespace. Okay, so we can see here the Jaeger query pod is in the crash loop backoff. So that means it is not serving the user interface. So that's why your port forward is failing, or when you try to access the user interface, it is sending the request to it and this pod is down. So obviously it cannot. Let's see why is it down. So if we quickly do kubectl describe pod followed by logging, sorry, tracing namespace. Okay, so it says that the liveness probe and readiness probe are failing. Okay, because the liveness probe and readiness probe are failing, the Jaeger user interface is not started. That's why we are not able to access. Cool. Let's see why the readiness probe and liveness probe are failing. Let me debug it. Okay, I just deleted the config map and secret because I think from my previous Elasticsearch instance, the config map and secret were mounted. Let me try again. I deleted that complete thing. So I will run the CA certificate again. And now I have updated the csr.pum. I have also deleted this file. Okay, let's do it again. The tracing namespace, it exists. Good. Let's create the config map from the csr.pem and let's create the secret as well. Perfect. Now let's, I have updated the Jaeger values, so I'm not doing it again. So now let's see if the pods are in running status or not. So all the pods, all the 4 components should be up and running of Jaeger. kubectl get pods hyphen f, hyphen n tracing. Perfect. So that was the issue at my end. Uh, I had an Elasticsearch instance before. I deleted the instance, but I forgot to delete its references. That is the config map secret. So when I'm trying to again integrate Jaeger with Elasticsearch, because the liveness probe and readiness probe failed, I immediately understood there should be something issue with the configuration because I use them a lot. And there I realized that, okay, it should be issue with the CA cert file or the certificate. So that's why I deleted the certificate related things. And now all the 4 pods are running. So this is how you need to troubleshoot as well. Cool. So now let's do this again, the port forwarding. If you don't want to do the port forwarding, very simple, go to the service, change the type as load balancer or create an ingress resource for it. Perfect. And let's reload the page. Cool. Now we have the Jaeger user interface. And the reason why I like Jaeger a lot is it does not complicate the tracing. It's very simple. Like if you provide the name of the service and if you provide the operation, that is the get operation or which API call that you are trying to look the tracing for, you will get the complete details. Click on the find traces and you get the complete details. Let's see that. Okay, so what I'm going to do is, of course, we need an application that is instrumented with the tracing, right? So in our GitHub repository, if you go to the day4 folder, you have two applications, service A and service B, which are instrumented with tracing using Open Telemetry. So you don't need to search for these applications on internet. You might find some applications, but they don't have tracing implemented. Open Telemetry is not available. Instead, just go to the day4 folder. And what you need to do, step one, create a namespace. Step two, just run this command. I mean, you need to check out this GitHub repository and go to the day4 folder and run this kubectl apply -k. And in the manifest, right, before you apply, just make sure the deployment files has the right image. So I have my image, you can use my image also. So check out this GitHub repository and run this command. Okay, service A created, deployment created. If you do kubectl get svc in the dev namespace, okay, so the service A has a load balancer. I mean, it's of a service of type load balancer. So I will access this application and I will run few things on this application. That is, I will run some APIs of this application so that it would be visible in the tracing, right? If you just have the application, it does not show in the Jaeger. Like, just search for it. You will not find anything. Like, refresh it multiple times. Still the services will be zero because the agent of the Jaeger, it is still searching for some tracing to find or to find some traces. So what you need to do is take this URL, paste it in the browser. It will take 2 to 3 minutes because AWS has to set up a load balancer for it. So wait for it. And these applications, so they have multiple endpoints, such as there is /healthy endpoint, /server error endpoint, call service B endpoint. So let's use these endpoints and then let's see if it is reflected in the Jaeger or not. That is, if Jaeger can provide me the complete route path or not. Okay, it's still not available yet. As I said, let's wait for 2 to 3 minutes. Perfect. Now the application is running. You can just refresh and see. Let me increase the font size. And as I told you, this application has multiple endpoints. Let's just hit /healthy. Okay, it said observability series by Abhishek.Veeramalla, status as healthy. This is the application that we have. Okay, now if you go to the Jaeger and refresh, you should see one service. Perfect. So you can see one service and the name of the service is service A because we used Open Telemetry in that application and we have instrumented the traces. Now in the Jaeger, select the operation, like, okay, all the operations, because we just have one particular request. And when you hit on the find traces, it will show you the complete path. That is how the request that you have hit /healthy, it took 6 spans. Spans are nothing but basically points. So in the example that I told you, Hyderabad to Boston, Hyderabad International Airport is a span. And then Dubai is a span. From there, Boston International Airport, that is a span. So traces are divided into spans. And each span, it tells you that when you hit /healthy, the request first went to the middleware query, then it went to the Express init. So we used Node.js application, right? The Express framework. So it went to the Express init. From there, it went to the logger. From there, it went to an anonymous function. And finally, it reached the healthy endpoint. And when you click on this, like on this particular span, Again, you will get the information that how much time did it take. It took 13 microseconds. Okay. And if you want to get information about this span, this one, this one. So if you have implemented the tracing, it will make life of developers easy so that if there are any issues, they can get all of this information. Imagine how useful is it for the developers when you have a request that goes through 10 services. So if a request goes through 10 services, this information will help the developers a lot to identify where there is a latency. Okay, this took 62 microseconds. This took 168 microseconds. So why did it take 168 microseconds? They will go to the code, they will go back, they will try to understand, okay, how can we improve this? Can we make it 100 microseconds in the next release? That can be a story and they can work on it. You can also do another example, like we hit on the slash healthy endpoint of service A, right? There is another endpoint in this application where service A will call service B. So this is the typical microservice architecture, right? A service talk to the another service. So I have provided you with that example as well. If you just do call to service B and click on the enter, okay, it said service B called hello from service B. Now, if you go back to the Jaeger interface, so you can immediately see number of services became 2. And if you select service B and click on the find traces, you will find that, okay, so the request to service B came from service A with 12 spans. That is like it went through 12 hops or 10 hops. First, it went to the middleware, then it went to logger, then it went to anonymous. Then from service A, request went to a function called call to service B. From there, it called the middleware of service B, express init, logger, slash hello, endpoint of service B, which returned you the required output. Again, you can click on each of these span and you can share this information with the developer, or if you grant access to your Jaeger to the developer, developers can go through all of this. Imagine how helpful it will be for the developers if you implement tracing in your organizations. Perfect. So this is the importance of tracing. If there is an issue, if there is interviewer might ask you like, what issue did you solve after implementing tracing? So you can give an example that there was a span called express init, or there was a particular function for the express initialization. And when I implemented the complete tracing, there was a issue that service A, service B communication is taking a lot of time. And after I implemented the tracing, I tried to see why it is taking more time. I implemented tracing using Jaeger and I shared this complete information with the developer. So developer could see this information and identify that, okay, maybe the HTTP routing is taking a lot of time. How can I reduce the latency? That way, the DevOps engineering team and development team together, we fix the issue with the latency. So you can explain this way. I hope you found this video informative. Make sure you try this example. It's very, very interesting. And you can also play a lot with the Jaeger user interface. Not only this part, you can also go to the system architecture. You can go to the monitoring part, where in the monitoring part, okay, so it requires the Prometheus time series database, which we haven't integrated yet. But you can get the information such as P99 latency and the other things, right? Thank you so much for watching today's video. See you all in the next one. Take care. Bye-bye.
Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will see an end-to-end observability project which is developed using a demo application that is developed specifically to learn observability. What does that mean?
The demo application that you see here is developed for demoing Open Telemetry and maintained by top observability companies like Datadog, Dynatrace, Microsoft, Alibaba, Grafana Labs. All of them together work on developing or contribute to the source code of this application so that anybody who wants to learn about Open Telemetry or observability can use this application for demo purpose. It's an open source project. You can look at the source code here. I will put the GitHub link in the description. And if you go to the SRC folder, you will find all the services and how telemetry is instrumented in these services. I will talk about the code in a while, but before that, you can see the architecture of this application. So the reason why I have chosen this application for the demo today, because this is the best project that is available on GitHub. It's a multi-microservice architectured application. Just like any e-commerce real-time application, it has cart service, currency service, payment service. For notification, there is an email service. Recommendation of the products, they have a recommendation service, shipping service, and each of it is written in different programming languages. Let's say you want to learn observability using Python. So you can find out the color. So this is the color, which means recommendation service, a microservice is written in the Python programming language. You can just go to the GitHub repository, search for recommendation service folder. You can see the Python application. And if you go to the code base, let's say you go here, you can see how Open Telemetry is used for writing the traces and metrics. You can find here, they are using the Open Telemetry module to import the traces and metrics. And within the code, they are defining the traces and metrics for this Python microservice. So by looking at the code, you can learn, if you are a developer, how to instrument the metrics and traces for Python application. And assume you are a DevOps engineer. If you go to the documentation, you have how to deploy this to Docker. You have how to deploy this application onto Kubernetes with detailed steps. That means using Helm charts, you can learn how to deploy it on a kind cluster, EKS cluster, everything step by step detailed is mentioned in the documentation. So end of the day, what I want to say is if you want to learn observability, this application is the best demo application that you can find on the GitHub, a open source project. Now, Abhishek, should we directly deploy it on a Kubernetes cluster and explore the metrics and traces? Before that, let me explain something very important. If you want to add it to your resume or if you want to learn observability, something that you have to note, which I mentioned in my observability series as well, where I explained observability right from scratch. In order to have a well set up observability, there are two things. First thing is instrumentation of metrics. Second thing is implementation of observability, where instrumentation means your development team who are writing the microservices. In our case, this demo application that is written by multiple observability companies. So these microservices should omit metrics, they should omit logs, and they should omit traces. No matter how simple or complex microservice that you are trying to implement observability, Let's say you are a DevOps engineer or SRE engineer and you want to implement observability. You are given an application, you are given a microservice. The first thing that you should ask is is the microservices instrumented with telemetry data? Telemetry data is nothing but metrics, logs, and traces. So you can also go to the source code, and in the source code, you can see. So if you have little development knowledge, for example, as I have shown you, so I went to the Python application and I looked at, okay, what libraries they are using, and in the code, at the critical functions, are they omitting the traces or are they scraping the metrics? Are they defining the metrics? I mean, everything you can look at the source code. For example, Go programming language. As a DevOps engineer, you have little understanding of Go, let's say, and you are given a Go microservice. In this application, I have used it multiple times before. So I know checkout service is written in Go. So you can go to this application and click on main.go, and you can see if Open Telemetry related things are used or not. So I can see in the modules, okay, the OTel, which is shortcut for Open Telemetry, they are using the trace module, and this trace module is also used in the code so that traces are omitted. Here I can see metrics are defined and exported. Perfect. So this is how observability is a team effort. It's combination of development team who are instrumenting metrics, traces, and logs, and DevOps engineers who are creating the Kubernetes clusters, DevOps engineers who are deploying the applications using Helm charts or operators, DevOps engineers who are setting up Grafana, Prometheus, and whatever is your observability stack, let's say Jaeger and other things. Now, Abhishek, okay, I have the application here, right? And I have the source code also. But one question that I always have is, why should we use Open Telemetry? And how does Open Telemetry actually work? So let's understand both of these things. First thing is, why should we use Open Telemetry? Or why should your development team use Open Telemetry? This question can be asked during your DevOps interviews as well. The reason for that is there are hundreds of observability tools in the market. Let's say today your company is using Datadog. Tomorrow your company is using Dynatrace. I mean, they want to move from Datadog to Dynatrace, or they want to move from Grafana to Jaeger, or Jaeger to Grafana. Anything, there are hundreds of observability tools in the market. And assume your development team who are writing the microservices today, because the metric stack that you're using is Prometheus. If your development team use Prometheus client, okay, let's say they are using Prometheus client or they are using Nagios client. Tomorrow, when you want to shift from Prometheus to Nagios, or when you want to shift from Datadog to Dynatrace, or one observability company to another observability company, hundreds of microservices that you have in your organization needs this change, because you have hard coded APIs of Prometheus, you have hard coded the SDKs of Prometheus, and using which you are defining the metrics. Tomorrow, if your company is moving to another observability stack, the development team has to go to each and every microservice, and they need to modify how metrics are defined. They need to modify how logs are defined. They need to modify how traces are defined. Now, this has become a very big problem in the industry, especially in the cloud native space, because moving from observability tool to other has become a very common thing. So what a common thing that CNCF has come with, or a project called Open Telemetry was developed or introduced, where they said that, okay, we will be a standard where instead of using Prometheus client, use Open Telemetry APIs and SDKs. And we have something called as exporter, where the developers can use APIs and SDKs of Open Telemetry instead of things like Prometheus, Nagios, or any specific thing. And in the exporter, you can define if we should expose the metrics to Prometheus, or if we should export the traces to Jaeger. We will do the job. So Open Telemetry has become a standard so that tomorrow, if you want to move from X to Y, it will not be a problem, because all of these observability companies have agreed to accept the standard, that is Open Telemetry. So now developers started using Open Telemetry APIs and SDKs. Same is in this demo application. Here you can see, although we are going to perform this demo on Jaeger and Grafana, Prometheus, you will not find the Prometheus client, or you will not find the Jaeger client. But in this demo application, you will find the modules and libraries related to Open Telemetry. OTel is shortcut for Open Telemetry. And then you have a file in this project, such as the exporter configuration file, where in that configuration file, you can define what should be your backend, or what should be the receiver of this metrics, logs, and traces. If you are confused, let me explain the architecture so that you will find things much easier. So this is how the configuration flow looks like. What typically happens is first, so this is the first step where developers, so they develop microservice, let's say. In the microservice, along with their code, the application code, maybe the Golang application code, along with that, what they will do is they will use the Open Telemetry API and SDKs for omitting metrics, logs, traces, and these metrics, logs, and traces, they are first received by a receiver component of OTel, that is Open Telemetry. So Open Telemetry has something called as receiver, which is going to receive this telemetry information. It will process it. So there is another OTel component called as processor, which is going to process all of this telemetry information. And finally, there is an exporter. So final OTel component is the exporter, which can export the metrics, logs, and traces to any backend that you need. So how is this defined? This is defined in the export configuration file of the Open Telemetry. Sounds good? So this is the standard that is defined by the Open Telemetry project, and that is why it has become very popular. So tomorrow you can just change this configuration file and update the backend to anything that you want. Let's say your backend for traces is Jaeger. As I have explained in the day 6 of Observability Zero to Hero series, where we learned about distributed tracing using Jaeger. Now what Jaeger does, if you have watched that video, as the exporter forwards this information, There is again a receiver in the Jaeger, or the agent in the Jaeger, which is receiving this information, which forwards the information to the Jaeger database, which is mostly Elasticsearch. And you can attach EBS volumes if you need, right, for backup and storage purposes. And finally, there is a UI component in the Jaeger where user through the user UI component can get this information using the Elasticsearch database. Or let's say the backend is, for the metrics, backend is Prometheus. Again, if you followed my Observability Zero to Hero series, where we learned about Prometheus, what happens in this case? There is a receiver component in Prometheus as well, which receives this information, or it can also scrape the information from the backend. And this information is updated in the time series database of Prometheus. And then there is a Prometheus HTTP server where user can fire PromQL queries and get this information. So this is how Open Telemetry has become vendor agnostic. Okay, now we talked so much about Open Telemetry. Let do this in action, where first we will take a EKS cluster. You can do it on kind cluster, you can do it on Minikube, anything that you want. So let me see if I already have an EKS cluster or not. EKS CTL get clusters. Okay, I already have the EKS cluster. If you are wondering, Abhishek, how can I get one? Don't worry. Go to our Observability Zero to Hero GitHub repository. Link will be in the description. Go to the day 2 folder. Go to the README file. You can find the complete steps for creating the EKS cluster. First, the prerequisites that you need, then run the EKSCTL command, associate the OIDC provider, create the node group. Every step is available. So you can just follow these steps, literally copy paste the commands, and you can get a EKS cluster. Okay, I have the EKS cluster with me. Now, what are the next steps? How to deploy this complex multi-microservice architectured application onto a Kubernetes cluster, right? How do we get this onto a Kubernetes cluster? So for that, just click on the Kubernetes. So this is the documentation link for the demo application. If you go to the GitHub project and if you scroll down, you will find the Docker and Kubernetes related documentation. Directly click on Kubernetes, you will go to that page. And make sure you focus sometime on the architecture. As I told you, it is very, very important project for your resume. If you want to talk about observability in your interviews, this project is going to help you a lot. Multi-microservices written in different programming languages, whichever programming language you are comfortable with, identify the color, go to that particular microservice, Python recommendation service, Go. Go is basically the product catalog service. Go to that GitHub repository, see how telemetry is instrumented, and finally come back to this official demo application documentation and click on Kubernetes. Two simple steps. First one is you need to add the Helm chart. Let me click on it. Okay, it says Helm chart is already available. Second simple step is just fire this command, Helm install my hotel demo, followed by the Helm chart, right? Open Telemetry demo. I already have this demo application up and running, because initially I wanted to show you at the beginning of the video how the UI looks and what exactly this application does. So if I just do, I've taken another tab, and if I just do kubectl get pods, you can see all of these microservices. So I think maybe 15, 16 pods, more than that, I think 20 pods, all of them related to this simple project. I mean, this single project. It's a complicated project, so that you can learn end to end, not only observability, you can use it for learning DevOps and cloud as well. Use it as your demo project. Perfect. So once the application is installed, now how do you expose this application? Because different people are using different Kubernetes clusters, what I would recommend is, just for your learning purpose, use port forwarding. So this is the command available in the documentation. kubectl port forward the front end proxy on the port 8080. Once the port forwarding is done, copy this 127.80.80, paste it on your browser. One important thing to note, if you are not doing this on your laptop, and let's say you are doing it on an EC2 instance or Azure VM, what you need to do to this port forwarding command, you need to just add hyphen address 0.0.0.0, and instead of accessing it on 127.0.0.1, access it on your EC2 instance public IP address. That's it. That's the only change if you are using a cloud instance. Okay, so now I executed the port forwarding command and I went to the application. Because you want to learn about observability, try to add few applications to the cart, try to perform some actions, so that once you have Jaeger, once you have Grafana, you can see the traces. Only if you execute few things, you can see the traces, right? Of course, this demo application also has a fake load generator. So even if you don't perform actions, you can see the load. But if you want to see your own request traces, if you want to see your own request metrics, better you add few things to the cart, change the currencies, click on multiple microservices of this demo application. Okay, now how do I access, let's say I want to learn the traces. How do I access the Jaeger user interface? Again, you don't have to do much for this demo application, because this demo application already comes with Jaeger installed. As you have executed this Helm chart, right? If you do kubectl get pods, you can see that Jaeger is already installed using this Helm chart. So again, you don't have to go to Jaeger official files, or don't have to go to my GitHub repository and find the steps how to install and configure Jaeger. Of course, if you want to do it with Datadog, if you want to use the same application with Datadog, then you need to go to the Datadog documentation, learn how to install Datadog using Helm chart, because for standardization, this project is coming up with Jaeger. If you want to change something else, this project definitely supports, but they cannot create 50, 100 observability pods. So they have used Jaeger, they have used Prometheus, and they have used Grafana. Okay, so what does the project say? Just provide this URL. So just append, or let me take a new tab and okay, my bad. Just do UI and you can see the Jaeger user interface. And you can see all 17 services. As I told you, there is a fake load generator in the project, which is generating the fake load so that you can understand different traces. So just select one of these services. Let's say I want to select the catalog service, or let's select the cat service. So click on find traces. You can find the complete traces of this application, which all microservices called the cart service. For example, the front end application called the cart service, and that request propagated. You can see the context propagation. So the context propagation happened from the front end web to the front end proxy, explained as explained in the architecture. First, there is a front end proxy. From there, front end. From there, we were looking at the cart service, right? So this is the cart service. So from there, the request has to go to the checkout service. From checkout, a gRPC request has to be made to the cart service. Let's see that in the traces, if it is correct or not. See, from there, it went to the, from front end, it went to the cart service. And within the cart service also, you can see to which service exactly it went, or the which function it went. It went to the get cart function. You can click on each span and you can see how much time each span took in the microseconds. You can see the container ID, the cloud region, where exactly it is installed on a EC2 instance of Kubernetes cluster. Everything you can get using this span information. If you want more details, just click on this arrow and you can get the complete details in the well formatted structure. Basically, everything that Jaeger provides. So similarly, you can also go to any other microservice. So we looked at the card service, right? So you can go back and you can look at any other service like checkout service and click on find traces. So there are 47 spans to reach out to the checkout service, because to check out a service, first you need to add an item to the cart. Only if you add an item to the cart, you can go to checkout. So that's why the span clearly explains that from front end, it goes to the cart service. From there, it goes to the checkout service. And if anything goes wrong as well, you can see in the traces very clearly. Now, Abhishek, okay, everything is clear with traces. Can I also see the metrics? Definitely. In the demo application, again, if you click on Kubernetes and scroll down, it also comes up with the Grafana user interface. Grafana is also installed using the same Helm chart. If you click on it, there is no username password that is required. Authentication is disabled. And in the Grafana dashboard, you can see there is a predefined dashboard, and you can also define a custom dashboard. So if you go to the dashboard section, there is already the demo dashboard that is available, where in the demo dashboard, you can see the latency that is occurred for the front end, the error rate for the front end. No, Abhishek, I don't want to use the default dashboards. Click on new, create a dashboard, add visualization. Of course, your backend has to be Prometheus, and you can fire your PromQL queries as well. One thing to note is this Prometheus instance or this Prometheus data source does not scrape metrics information related to the nodes as well as related to your Kubernetes cluster. For example, let me do pod. So you can see there is no information related to the pod. Even the suggestions does not show me anything. Or let's say I want to get any node CPU related information. There is nothing about it. Why? Again, as I've explained in the previous classes, for Prometheus to scrape metrics from the nodes, or to scrape metrics from the database, or to scrape metrics from the Kubernetes clusters, what Prometheus needs is exporters. If you look at the pods that are installed, you will not see kube state metrics pod. You will not see the node exporter pod. So that's why Prometheus cannot get any information about the underlying nodes or the Kubernetes cluster. If you want to do that, you need to install the node exporter. You need to install the kube state metrics. For that, just go to day 3 folder and you can see how kube state metrics can be installed. Sorry, day 4 folder, and you can install Prometheus with the complete Prometheus stack so that kube state metrics and node exporter are installed. Or you can do it on your own as well. So you can fire a PromQL query. Let's say I want to get the HTTP server duration seconds bucket. So fire a query and you can see different services here. There is a flag service. And if you reduce the time span, let me do it for 5 minutes. So you can see the HTTP status code. You can see the HTTP server duration of this flag service for the last 5 minutes. Similarly, change the different queries that you want. If you want anything related to the app recommendation, so there is a recommendation service, right? And within the recommendation service, in this GitHub repository, there is a counter that is defined for the number of recommendations it is showing. If you run this query and change for, let's say, 1 hour or change for 5 minutes, you can see if it has suggested any recommendations for us. Of course, this application did not show any recommendations for us, right? Right now it is showing, but before, when we added the application to the cart, it did not show any recommendations for us. That's why the query is returning 0 values. Perfect. So this is how you can play with Grafana. You can play with Jaeger. That means metrics and traces using this Open Telemetry demo application. It is worth spending time on the architecture, spending time on the code base, even though you don't understand the application code, even if you're not a developer, just spend some time within the programming language of your choice and see what exactly they are doing for instrumenting the metrics. For the Kubernetes part and Docker part, things are pretty clear in the documentation. Links will be provided. You can play around with observability. If you have any questions related to this project, or if you want me to cover anything specific for this project, let me know in the comment section. I will definitely take out time and do it. See you all in the next video. Take care. Bye bye.